Hello there, and welcome to Space Sleep Journey, where curiosity takes the gentle shape of a bedtime story and science moves at the pace of a quiet breath. I am so glad you are here tonight. There is nowhere you need to be for the next little while, and nothing you need to do except rest and breathe, and let your mind wander softly out among the stars while your body grows heavy and still. Tonight we will be wandering toward one of the strangest and most beautiful questions in all of space. What is a blitzar really? And could a single flash of light, lasting only 1,000th of a second, arriving from the far edge of the universe, truly be the last cry of a dying star as it falls into a black hole? It is a question about the briefest events we know, flashes so quick you could blink and miss 10,000 of them, and yet so powerful that for that 1,000th of a second, a single point may outshine every star in its home galaxy combined. We will take our time with it. We will drift slowly and wonder gently and let the strangeness carry us down towards sleep. Before we begin, I always love to wonder where you are listening from tonight. Perhaps you are in a bright and busy city where the glow of the streetlights washes the stars away and the sky above the rooftops is a soft and empty grey, and you have to take it on faith that the stars are even there at all. Or perhaps you are somewhere quiet and far from the lights, out in the countryside, where on a clear night the whole Milky Way spills overhead like scattered sugar across black velvet, and the dark is deep enough to swallow you whole. Wherever you are, in whatever corner of this turning world, city or country, near or far, we are all resting tonight beneath the very same sky, the same vast dark, the same silent flashes blooming far away. And for this little while, we get to wonder about them together. If you find some peace in this slow wandering, I would be grateful if you tapped like or subscribed so that others who need a quiet voice tonight can find their way here too, into the calm, when the dark feels wide and sleep is slow to come. And now, take a breath. A slow one, all the way in, and let it out gently. Settle into your chair or your pillow, and let your shoulders soften, and let the weight of the day begin to slip away. There is nothing left to carry now. Let yourself grow comfortable and warm and still. Imagine the night is clear and cool, and the stars have come out one by one until the whole sky above you is scattered with their light. Imagine you are lying somewhere soft and open, looking up, with the quiet all around you, and no sound but your own slow breathing. And now imagine that somewhere out there, farther away than you have ever let yourself picture, farther than the nearest stars, farther than the edge of our own galaxy, out across an ocean of empty space so wide that light itself takes billions of years to cross it, a star is about to die. Not slowly, the way our own gentle sun will one day fade, but all at once in a single blinding instant. A star that has already died once, and has been holding itself together ever since by spinning faster than anything so heavy has any right to spin, is about to lose that long, patient fight. And when it does, it will send out one flash of radio light, a single clean note struck from a bell in the very moment the bell is swallowed, and then it will fall silent forever. That flash has a name. given to it by two scientists who dreamed it up to explain a real mystery in the sky. They called it a blitzar, from an old word for a sudden flash and the name of a certain kind of spinning star. And tonight, slowly, gently, with all the time in the world, I would like to wonder about it with you from the very beginning until you drift off somewhere along the way. So let us begin. Somewhere out in the dark, farther away than you have ever let yourself imagine, a star is about to die. The slow, gentle death of our own sun, which still has billions of years of quiet burning ahead of it. This is something faster, something stranger. A star that has already died once and has been holding itself together ever since by spinning is about to lose that fight. And when it does, it will send out a single flash of radio light. A flash so brief you could blink and miss 10,000 of them. Flash so bright that, for that 1,000th of a second, it may outshine every star in its home galaxy combined. That flash has a name. We call it a blitzar. And tonight, I would like to sit with you and wonder about it together, slowly, the way you might turn a smooth stone over and over in your hand before you fall asleep. The word itself is a small joke made by scientists, the kind of quiet joke that gets folded into a serious paper. It comes from two older words pressed together. The first is blitz, an old word for a sudden flash, a burst of light out of nowhere. The second is pulsar, the name we give to a certain kind of dead star that spins and sweeps a beam of radio waves across space like a lighthouse. Put them together and you get blitzar, a flash from a spinning star, a single blinding goodbye. Now I want to be honest with you from the very beginning, because honesty is part of what makes this restful. A blitzar has never been caught in the act. No telescope has ever pointed at the sky and said, "There, that flash. That was certainly a star falling into a black hole." The blitzar is an idea. Careful, beautiful idea, dreamed up by two scientists who were trying to explain a real mystery in the sky. Their names were Heino Falcke and Luciano Rezzolla, and they wrote the idea down in the year 2014. What they were trying to explain was real. They proposed as the cause is still, to this day, only one possible answer among several. So as we walk through this together, hold it gently. This is a story about a thing that might be true, and about all the clever ways we have learned to tell the difference between a good guess and a proven fact. But let me paint the picture for you first, before we start asking how we know anything at all. Let me just tell you what a blitzar would look like if you could somehow stand far enough away to be safe and close enough to see. Picture a star. Not a star like the ones you see when you look up on a clear night, those calm points of light that seem to hold perfectly still. This star is small, astonishingly small. If you set it down on the earth, it would not cover a country or even a large state. It would stretch about as wide as a single city, perhaps 12 to 15 miles across, no bigger than the distance you might drive in a spare afternoon. And yet inside that city-sized ball is more matter than there is in our entire sun. More than 1,000,000 Earths, crushed down into a sphere you could drive across in 20 minutes, if driving across the surface of such a thing were not the last thing you would ever do. This is a neutron star. We will spend a long, slow while getting to know it, because you cannot understand the flash without understanding the thing that makes it. But for now, just hold the strangeness of it. A single spoonful of this star, if you could scoop it up and set it on a kitchen table, would weigh about as much as a mountain. Somewhere near 6 billion tons in a single teaspoon. The matter is packed so tightly that the empty space inside atoms, the vast echoing space that makes up almost everything you have ever touched, has been squeezed nearly all the way out. And this particular neutron star is spinning. That is the important part. It is spinning very, very fast, faster than anything so heavy has any right to spin. Some neutron stars turn hundreds of times every single second. Imagine an object heavier than the sun, turning around completely in less time than it takes you to say the word now. The spin is not just a detail. The spin is the only reason this star is still here at all. Because this star is too heavy to exist. That is the strange truth at the center of the Blitzar idea. There is a limit to how much a neutron star can weigh and still hold itself up. Push past that limit and gravity wins, and the whole thing falls inward and becomes a black hole. Most neutron stars sit safely below the limit. But some, a rare few, are born heavier than the limit should allow. They should collapse the moment they fall. And they would, except for one thing. They are spinning so fast that the spin itself holds them open, the way the water in a bucket stays in place when you swing it fast enough around your head. The spinning flings the matter outward just enough to fight against the crushing pull of gravity. Take away the spin, and there is nothing left to hold the star up. We have a name for a star like this, a star kept alive only by how fast it turns. We call it a supramassive neutron star. The word supramassive simply means above the mass, above the weight that should be allowed. It is a star living on borrowed time. It is a spinning top that has already been knocked and is only waiting to fall. And here is the quiet tragedy of it. A spinning star cannot spin forever. Slowly, over seconds, or years, or even longer, the star bleeds its spin away into space. It has a powerful magnetic field, and as it turns, that field stirs the space around it and radiates energy outward, and every bit of energy that leaves carries away a little of the star's spin. It is a little like a child on a merry-go-round who keeps brushing one foot against the ground. Each brush is small, but the spinning cannot last. The star slows and slows and slows, and you already know what waits at the end of the slowing. When the star has finally lost enough of its spin, there is no longer enough outward push to fight gravity. The limit is crossed. And the star, which has been holding itself open for perhaps thousands of years, gives up all at once. It collapses. Not slowly. It falls inward at nearly the speed of light, the whole city-sized star crushing down toward a single point in a fraction of a heart. What forms in that instant is a black hole, a region where gravity has become so strong that nothing, not even light itself, can climb back out. Around it forms an edge we call the event horizon, a boundary in empty space with no wall and no surface, a simple line beyond which there is no return. The star that was there a moment ago is now inside that line, and it is gone from the universe forever, sealed away where no signal can follow. But not quite everything is sealed away. And this is where the flash is born. The neutron star, before it fell, was wrapped in that enormous magnetic field. Think of the field as a great tangle of invisible lines, threads of magnetic force anchored deep in the star and stretching far out into the space around it. For thousands of years those lines had a home. They were rooted in the star's surface, held there by the star's own matter. In a thousandth of a second, the surface they were anchored to falls out from under them and vanishes behind the event horizon. And here the universe reveals one of its strangest rules. A black hole is not allowed to keep a magnetic field of its own, not in the way a star can. Scientists sometimes say a black hole has no hair, which is their odd, memorable way of saying a black hole is almost featureless, described by only its mass, its spin, and its charge, and nothing more. All the rich, tangled detail of the old magnetic field cannot go inside with it. The field lines are suddenly homeless. Their anchor is gone. So they snap. Picture a bundle of cables stretched tight and then cut all at once. They whip and recoil and lash the empty space around them. The magnetic field lines released from the star that held them do the same. They snap outward, and in snapping they shake the thin scattering of charged particles around the dead star, and shaking those particles sends out a wave of radio light. Not visible light, not the kind your eyes could see, but radio waves, the long, calm cousin of the light we see, the same family of waves that carries a song to a car radio. And that wave of radio light is the Blitzar. A single coherent burst lasting about 1/1000th of a second, carrying the last word of a star that has just fallen silent forever. The star does not fade, does not dim over days. It simply says one last thing, in one brilliant flash, and then it is a black hole, dark and quiet, and it will never speak again. That is the picture. That is what a Blitzar would be, if Blitzars are real. Too heavy star, held up by its own dizzying spin, slowing over the ages, crossing a line it was never meant to cross, and collapsing into darkness while its magnetic field snaps free and rings out across the cosmos like a struck bell. One note. 1,000th of a second, and then nothing. Now, you might be lying there wondering something very reasonable. If no one has ever seen a Blitzar happen, if it is only an idea, then where did the idea even come from? Why would two careful scientists sit down and invent such a thing? People do not usually dream up dying stars for no reason. And they did not. The Blitzar was invented to answer a real question, a genuine mystery that had appeared in our telescopes and refused to go away. A mystery that arrived, fittingly, as a single flash. To understand why anyone proposed the Blitzar, we have to go back to a quiet afternoon of ordinary work, to a scientist looking through old data that everyone else had already set aside, and to the moment he found something that should not have been there. We have to talk about the flash that started it all. But before we can even do that, before any of it will make sense, we need to slow down and really understand the strange object at the heart of the whole story. We need to understand the neutron star, because everything about the Blitzar, the spin, the limit, the collapse, the snapping field, all of it grows out of what a neutron star actually is. And a neutron star is one of the most extreme things that exists anywhere in creation. So let us step back and take our time and build the whole thing up from the beginning. Let us start with how a star like this is even born. And to see that, we have to start with an ordinary star, living an ordinary life, and follow it all the way to its violent and beautiful end. Think of a star much larger than our Sun, one of the calm, middle-sized stars like the one that warms our mornings, but a giant, a star with perhaps 10 or 20 or 30 times the mass of the Sun. For millions of years, that star does what every star does. Deep in its core, it presses hydrogen together so hard that the hydrogen fuses into helium, and that fusion releases a steady flood of energy that pushes outward. And all the while, gravity is pulling inward, trying to crush the star down. A star's whole long life is really just this one quiet argument held in perfect balance. The push of fusion out, the pull of gravity inward. As long as the two stay equal, the star shines on, steady and calm. But fuel runs out. It always does. When the giant star has fused its hydrogen into helium, it starts fusing the helium into carbon. Then the carbon into heavier things still. Ion, oxygen, ion, silicon. Each stage is faster than the last, each a shorter and more frantic chapter than the one before. Millions of years at the start now takes only thousands, then years, then days. The star is burning through the last of everything it has. And at the very end, in its core, it fuses its way up to iron. Iron is where the argument is lost. Iron is the ash at the bottom of the fire. When you fuse iron, it does not give energy back. It takes energy away. And so the moment the core of that great star turns to iron, the outward push simply stops. the fire that held up the star for its entire life goes out in an instant. And gravity, which has been waiting patiently all along, finally wins. Core of the star, something larger than our sun, collapses in about 1 second. 1 second. The inner part falls inward at speeds you can barely hold in your mind, a quarter of the speed of light, crushing down until the atoms themselves can no longer keep their shape. And here something remarkable happens. The protons and electrons that make up ordinary matter are squeezed so violently together that they merge and become neutrons. The whole core turns into a single, unimaginably dense ball of neutrons pressed shoulder to shoulder with almost no gap between them anywhere. That ball is the newborn neutron star, and the collapse that made it releases so much energy that the outer layers of the old star are blown off into space in a titanic explosion. We call that explosion a supernova, and for a few weeks it can shine as brightly as an entire galaxy, bright enough that people on Earth have written down the sight of them for thousands of years, new stars appearing in the sky where none had been before. The real wonder is not the explosion. The real wonder is the small, dense, spinning thing left behind at the center. The neutron star. The seed of our whole story. Let me try to give you a feel for just how dense this newborn thing is, because the numbers alone slide off the mind, and I would rather you feel it than simply hear it. The star that made it was wider than 1,000,000 Earths lined up. What is left is a ball about 12 to 15 miles across. All that mass, more than the whole sun, folded down into something the size of a city. If you could somehow carve out a single sugar cube of neutron star matter, one small cube you could balance on your fingertip, cube would weigh about as much as every human being on Earth put together. All 8 billion of us in a lump you could hide in your closed hand. And here is the part that matters most for a Blitzar. When the core collapses, it spins up. You have felt the reason for this yourself, even if you have never named it. When an ice skater is turning slowly with her arms held out wide, and she pulls her arms in close to her body, she suddenly spins faster, much faster, without any effort at all. She has not pushed against anything. She has simply gathered her spinning mass into a smaller space, and the spin has nowhere to go but faster. The giant star was turning slowly, lazily, over many days. When its core collapses down to the size of a city, that same spin is gathered into a tiny space, and the neutron star is left whirling around not once a day, but tens or even hundreds of times every second. Sit with that for a moment. A ball heavier than the sun, wider than a city, turning completely around in the time it takes a hummingbird to beat its wings once. There is nothing gentle about it. The surface of a fast neutron star is moving at a good fraction of the speed of light. And because the star also carries a magnetic field, a field trillions of times stronger than the gentle one that tugs a compass needle here on Earth, that spinning, magnetized ball becomes a kind of natural machine, a cosmic dynamo, flinging beams of radio waves out into space from its magnetic poles. Those beams are how we first came to know neutron stars at all. As the star spins, the beams sweep around, like the light of a lighthouse turning through the night. And if the Earth happens to lie in the path of one of those beams, then every single time the beam sweeps past us, our telescopes catch a tick, pulse. And then, a fraction of a second later, as the star turns again, another. And another. Perfectly, impossibly regular. Yick. 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 When the first of these was found, back in the late 1960s, the astronomers who found it were so unsettled by how regular it was that they half-seriously labelled it with the letters standing for little green men, wondering for a moment whether they had stumbled onto a signal from another civilization. Nothing natural, they thought, could keep time so perfectly. But it was natural. It was a neutron star, spinning and sweeping its beam past the Earth many times a second, a clock built by gravity out of the corpse of a giant. We named this kind of star a pulsar because of the pulses. And you can already hear in that word the first half of the word Blitzar waiting to be born. So a pulsar is simply a spinning, magnetized neutron star whose beam happens to cross our sky. And this tells us something we will need later. A spinning neutron star loses its spin over time. We can actually watch it happen. The pulses from a young pulsar come just a hair further apart with each passing year, because the star is very, very slowly slowing down. The magnetic field dragging through the space around the star acts like a brake, bleeding away the spin and radiating that energy off into the dark. It is a gentle, patient braking, but it never stops. Every pulsar we have ever found is slowing down. Given enough time, every spinning neutron star winds down like a top losing its balance. For most neutron stars, this slowing is nothing to fear. They are light enough to hold themselves up without any help from their spin. They can slow all the way to a crawl and still stand, cooling quietly over billions of years, fading into the dark. But now bring back the strange one, the rare one, the one that was born too heavy. The supramassive neutron star, whose weight is over the limit, and which is only standing at all because it is spinning so fast. For that star, the slowing is not a gentle old age. For that star, the slowing is a countdown. Let us make sure we truly understand that limit, because it is the hinge on which the entire Blitzar story turns. Why is there a ceiling on how heavy a neutron star can be? Why can gravity crush some of them and not others? It comes down to a contest between two things. On one side is gravity, pulling everything inward, and the more mass a star has, the harder gravity pulls. On the other side is the stubbornness of the neutrons themselves. Neutrons, when you pack them tightly enough, push back. They resist being squeezed into the same space, a resistance that comes from the deep rules of the very small, the rules of the quantum world. This pushing back is called degeneracy pressure, and for an ordinary neutron star, it is enough. The neutrons hold the line against gravity, and the star stands. Degeneracy pressure has a ceiling. Pile on more and more mass, make gravity's pull stronger and stronger, and eventually you reach a point where the neutrons simply cannot push hard enough. Gravity overwhelms them. And once gravity wins, there is no stopping it. Nothing known can hold matter up past that point. The star collapses and keeps collapsing, past the size of a city, past any size at all, down toward a single point, and a black hole is born. Scientists have a name for that ceiling. They call it the Tolman-Oppenheimer-Volkoff limit, after the three researchers who first worked out that such a limit had to exist. It is a mouthful, and you do not need to hold the name. You only need to hold the idea. There is a heaviest a still neutron star can be. Our best measurements today put that ceiling at somewhere around 2 1/10 to 2 2/10 times the mass of the Sun, though the exact figure is still being pinned down, and honest scientists will tell you the number carries some uncertainty. Below the ceiling, a neutron star can rest. Above it, gravity takes everything. Now here is the twist that brings the supramassive star to life. That ceiling, the one we just described, is the ceiling for a star that is standing still. A star that spins gets to cheat. When a neutron star whirls around fast enough, the spinning flings its matter outward, and that outward fling adds to the neutron's push, helping them hold gravity off. A rapidly spinning neutron star can therefore carry more weight than a still one, perhaps up to a fifth more, and not collapse. Can stand above the ordinary limit as long as it keeps spinning fast enough. This is the supramassive neutron star. Not simply heavy, but heavier than a still star could ever be, and holding itself up on nothing but the speed of its own turning. And you already know the ending written into that arrangement. The spin does not last. The magnetic braking never rests. Year by year the star turns a little slower, and its borrowed strength drains away, and the day comes when the spin is no longer fast enough to help. On that day the star crosses back below the line. It had been cheating, and there is nothing left to hold it up. It falls. And as it falls, it rings out its one last note, the Blitzar, and is gone. So now you can see why we had to build the neutron star up so carefully. The whole drama of the Blitzar is really the drama of that limit. A star living just barely on the safe side of a cliff, kept there only by spinning, slowly losing the very thing that keeps it from the edge. It is almost unbearably patient, this process. The star may hold on for seconds after it forms, or it may hold on for many thousands of years, depending on how fast it was spinning to begin with and how quickly its brake bleeds the spin away. But the outcome never changes. Cliff is always there. The spin always fades. And the fall always comes. There is one more thing we should understand before we go on, because it will matter later when we ask how we could ever hope to catch such a thing. We need to know where a supramassive neutron star comes from in the first place. An ordinary neutron star is born from the death of a single giant star, as we saw. But an ordinary supernova rarely leaves behind something over the limit. To make a star that is too heavy to stand still, and spinning fast enough to survive anyway, nature usually needs something more dramatic. And the most dramatic path of all involves not one dying star, but two. Imagine two neutron stars, both born from separate giant stars, but born as partners, circling one another. This happens more often than you might think, because giant stars often come in pairs to begin with, two of them orbiting through space together for millions of years. When both of them die, both leave behind neutron stars, and those two dense little corpses go on circling each other, bound by gravity, tracing tighter and tighter loop. And they cannot circle forever, because two heavy bodies whirling around each other stir the very fabric of space, and that stirring carries energy away in ripples we call gravitational waves. We will come back to those ripples later, because they matter enormously to our story. For now, just know that with every orbit the pair loses a little energy to those ripples, and with every bit of energy lost, they draw a little closer. Over millions upon millions of years the loops shrink, slowly at first, and then, at the very end, with terrifying speed. In the final second, the two neutron stars are whipping around each other hundreds of times, almost touching, moving at a good fraction of the speed of light. And then they meet. When two neutron stars collide, the result depends entirely on how much matter they carry between them. If the combined weight is far over the limit, the merged object collapses into a black hole almost at once, in far less than the blink of an eye. But if the combined weight lands in just the right window, only a little over the limit, then something more interesting can happen. The merged star is spinning ferociously because all the orbital whirling of the two partners has been gathered into one body. And that furious spin can hold the too heavy star up, at least for a while. What is born from the collision is a supramassive neutron star, spinning near the very edge of what is possible, standing on borrowed time, exactly the kind of star a Blitzar needs. There is a second way to build one, gentler and slower. Take an ordinary neutron star that has a living companion star still burning beside it. The neutron star's gravity can pull a steady stream of gas off its companion, and as that gas spirals down and lands on the neutron star, it does two things. It adds mass, nudging the star up toward the limit. And it delivers spin, like water pouring onto the edge of a wheel, driving the star to turn faster and faster. Given long enough, a neutron star fed this way can be spun up to enormous speeds and loaded with extra weight until it too becomes supramassive, too heavy to stand still, kept upright only by the blistering spin it has been given. This gentler path takes far longer, but it arrives at the same fragile place. Either way, by merger or by feeding, nature has now built the thing at the heart of our story. A neutron star that should not exist. A star over the line, held open by its own spinning, a spinning top already knocked and only waiting to fall. And from the very moment it forms, the clock is running, because the magnetic brake has already begun its patient work. Let us walk through the fall itself, slowly, one step at a time, because it is the most dramatic thing in the whole story, and it happens faster than any story can be told. In real time, the ending we are about to describe unfolds in about 1,000th of a second. But we are in no hurry tonight. We can stretch that 1,000th of a second out as long as we like and look at it from every side. For thousands of years, or perhaps only for seconds, the star has been slowing. The magnetic field, sweeping through the space around the spinning star, drags against it and steals its spin, radiating that stolen energy off into the dark as the star turns. This is the same braking that slows every pulsar we have ever watched, only now the stakes could not be higher. Each year the star turns a hair slower. Each year the outward fling of its matter grows a hair weaker, and the star drifts, without ever meaning to, back toward the limit it had been cheating. Then comes the moment. The spin drops just below the speed needed to hold the extra weight aloft, and in that instant, the whole careful balance that has stood for ages simply fails. Gravity, which never rested, never grew tired, never looked away, finally has more pull than the star has strength. And the star begins to fall inward. Does not crumble slowly. Does not sag. The entire city-sized ball, heavier than the sun, drops toward its own center at nearly the speed of light. There is no fire this time, no explosion thrown outward as in a supernova. This is a collapse turned entirely inward, silent and total. In a fraction of a heartbeat, the star shrinks past the size of a town, past the size of a single building, past any size that would mean anything to you, racing toward a point. And somewhere in that fall, a boundary forms in the empty space around the shrinking star. Not a wall. Not a surface. Nothing you could touch or see. Just a line, a threshold, drawn in nothing at all, marking the place where gravity has grown so fierce that not even light moving at its full and absolute speed can escape from within. We call that threshold the event horizon. Once the surface of the collapsing star crosses inside it, the star is gone from our universe. Not destroyed exactly. Healed. Walled off behind a boundary that lets nothing out. A black hole has been born. Now here is the exact instant the Blitzar lives in, the razor-thin sliver of time that the whole idea depends upon. Picture the star in the final moment before the horizon closes over it. It is still wrapped in that vast magnetic field, that enormous tangle of invisible lines rooted deep in the star's matter and reaching far out into the space around it. Those lines have been anchored there for the star's whole life. They belong to the star, the way a shadow belongs to the thing that casts it. And then the thing that cast them falls behind the horizon. Here, the universe applies one of its most unbending and beautiful rules. A black hole, it turns out, is almost featureless. It cannot carry the rich, complicated magnetic field a star can carry. Scientists put this in a strange little phrase. They say a black hole has no hair, meaning it has no messy individual details, no personality written into a magnetic field. A finished black hole can be fully described by only a few simple numbers: how much it weighs, how fast it spins, and its electric charge, and nothing else. All the intricate structure of the old star's magnetic field is exactly the kind of hair a black hole is not allowed to keep. It cannot go in. So it is expelled. In the instant the star vanishes behind the horizon, the magnetic field lines that had been rooted in its surface suddenly have no anchor at all. Their foundation has fallen out of the universe. And a magnetic field cannot simply hold still with nothing to hold it. The lines snap outward, released all at once, like a great bundle of cables cut at the base and flung free. They recoil into the space around the new black hole, whipping and shaking as they go. And as those field lines lash outward, they shove hard against the thin haze of charged particles that always surround such a star, the electrons and other bits of matter drifting in its magnetosphere. The lashing field slams into them and drives them outward in a tight, coordinated pulse. When enormous numbers of charged particles are shaken together, in step all at once, they radiate. Not a scatter of random noise, but a clean, coherent wave of radio light, all singing the same note together. That coherent wave is the loudest thing the dying star will ever produce. It races outward across the cosmos at the speed of light, a single pulse about 1,000th of a second long, carrying the news that a star has just become a black hole. Pulse is the Blitzar, the last word. The one clean note struck from a bell that will never ring again. Behind it, where a spinning star stood a heartbeat ago, there is now only a black hole, silent and dark, giving nothing back. The magnetosphere is gone. The spin is swallowed. The flash is already speeding away, and it will keep speeding away for millions or billions of years, crossing an ocean of empty space, until perhaps one ordinary day on a small blue world washes over a dish of metal that someone built to listen. And this brings us, at last, to the mystery that started everything. Because before Falcke and Rezzolla ever dreamed up the Blitzar, before anyone imagined a star ringing out as it fell into darkness, our telescopes had already caught something they could not explain. A flash. The single, impossibly bright flash of radio waves, gone almost before it arrived, coming from somewhere far outside our own galaxy. No one knew what made it. No one could even agree, at first, that it was real. It sat in the data like a riddle with no answer. And it is that flash, and the long, strange hunt to understand it that we turn to now. The story of the flash begins not with a discovery in the night, but with a young researcher looking back through old records that everyone else had already finished with. This is often how the deepest things are found. Not by pointing a telescope at the right patch of sky at the right moment, which would take almost impossible luck, but by combing patiently back through mountains of data that a great instrument has already gathered, searching for the one strange thing that slipped past unnoticed the first time. The great instrument in this case was a radio telescope in Australia, a single enormous dish set among sheep paddocks known as the Parkes telescope. For years it had been sweeping the southern sky, listening to the faint radio hiss of the cosmos, recording everything, storing it all away. And in the year 2007, a scientist named Duncan Lorimer, working with a student, went digging back through recordings the telescope had made 6 years earlier, in 2001. They were not even looking for anything so grand. They were hunting for pulsars, those steady ticking neutron stars going through the archive pulse by pulse. And there, buried in old data no one had thought twice about, they found it. A single burst of radio waves. Enormously bright, brighter than almost anything around it. And over almost as soon as it began, lasting less than 5,000ths of a second before it vanished completely and never came again. One flash. One only. No repeat, no echo, nothing before it and nothing after. Just a single, brilliant shout from the dark recorded years earlier and waiting all that time to be noticed. We call it the Lorimer Burst now, after the man who found it. And when it was found, almost no one believed it meant anything. A single flash could be so many ordinary things. It could be a fault in the electronics. Could be a burst from a lightning storm, or a spark from a passing satellite, or, as astronomers would later discover to their great embarrassment, the signal of a microwave oven door being opened too early in the telescope's own kitchen. The sky is full of false alarms. A lone flash, seen once and never again, is the easiest thing in the world to dismiss. And for years many people did dismiss it. There was one detail about the Lorimer Burst that would not let it be dismissed. One fingerprint in the flash that said, plainly, this did not come from here. This came from very, very far away. To understand that fingerprint, we need to slow down and learn one of the most beautiful tricks in all of astronomy, a trick that turns a simple flash of light into a measuring tape stretched across the universe. Because this is the heart of the whole hunt. Not just that we saw a flash, but how from that one flash we could tell it had crossed an ocean of space to reach us. Here is the idea, and it is gentle enough to follow half asleep. A flash of radio waves is not made of just one note. It carries a whole range of radio frequencies at once, high notes and low notes together, the way a hand clap contains many pitches at the same time. When that flash sets out from its source, all of its notes, high and low, begin the journey together in perfect step, leaving at the very same instant. but the space between the stars and between the galaxies is not truly empty. It is filled ever so thinly with a haze of loose electrons, a scattering so faint that a whole roomful of that space might hold only a handful of them. Light barely notices it. But over billions upon billions of miles, even the faintest haze adds up. And this thin fog of electrons does something subtle and wonderful. It slows down the low notes of the flash just a little more than it slows the high notes. The high frequencies slip through almost freely. The low frequencies drag ever so slightly all along the way. So a flash that set out with all its notes in perfect step arrives at our telescope smeared out in time. The high notes reach us first. Then, a moment later, the middle notes. And last of all, trailing behind, the low notes finally arrive. Began as a single instant has been stretched into a swift downward sweep, a slide from high pitch to low, like the fading whistle of a train that has already passed. And the length of that sweep, how far the low notes lag behind the high ones, tells us exactly how much of that thin electron fog the flash had to pass through on its way to us. Astronomers have a name for this measurement. They call it the dispersion measure, because the flash has been dispersed, spread out, by the fog it crossed. And the dispersion measure is a kind of odometer. The more fog a flash passed through, the more its notes were spread apart, and so the larger its dispersion measure, the farther it must have travelled. A flash born nearby, inside our own galaxy, crosses only a little fog and arrives barely smeared. A flash born far outside our galaxy crosses vastly more fog and arrives with its notes spread wide. And this is exactly what betrayed the Lorimer Burst. When Lorimer and his colleagues measured how far its low notes lagged behind its high ones, the answer was staggering. The amount of electron fog the flash had crossed was many times more than the entire Milky Way could possibly account for, even if the flash had travelled all the way across our galaxy and out the other side. There was simply no way to explain that much dispersion with anything inside our own galaxy. The flash had to have come from far beyond it. From another galaxy hundreds of millions of light years away, across a gulf of space so wide the number barely means anything. The single doubted flash had left a fingerprint, and the fingerprint said plainly, "I am not from your world." Changed everything slowly. Because if the flash truly came from that far away and still arrived at Parkes bright enough to stand out, then whatever made it must have released an almost unthinkable amount of energy. Light spreads out and fades as it travels. A flash, still shouting after crossing hundreds of millions of light years, must have started as one of the loudest events in the entire universe. Let me try to give you a sense of how much energy that means, because this is one of the places I would like you to simply rest in the scale of it. Think of our sun. Every second, our sun pours out more energy than all of human civilization has used in its entire history. It has been doing this for over 4.5 billion years, without pause, and it will go on doing it for billions more. Now take everything the sun radiates, not in a second, not in an hour, but across 3 entire days, every drop of sunlight and warmth and light it sheds in 3 full days. Gather all of that up. That is roughly how much energy one of these flashes releases. And it releases it not over 3 days, but in about 1,000th of a second. 3 days of sunshine from a star that lights a whole solar system poured out in less time than it takes you to blink. And some of these flashes are far more extreme still. One of them, caught crossing the sky some years ago, was measured to have released in its single millisecond about as much energy as the sun pours out across 30 entire years. 30 years of one star's whole output spent in a flash briefer than a heart. For that 1,000th of a second, such a flash can shine in radio light brighter than every star in its home galaxy put together. A single point briefly outshining 100 billion suns. And yet, by the time that titanic flash has crossed the vast gulf to reach us, it has faded so much that catching it on Earth is like sensing a whisper from across an ocean. The signal that arrives at our great dishes is astonishingly faint, no stronger, some have said, than the signal of a mobile phone sitting on the surface of the moon. That is the strange doubleness of these flashes. The source, one of the most violent releases of energy the cosmos allows. At our end, the faintest of murmurs, so quiet that for years we were not even sure it was there. Once people finally accepted that the Lorimer Burst was real and truly came from far away, the hunt was on. Astronomers gave the phenomenon a plain and fitting name. They called these flashes fast radio bursts. Fast because they last only thousandths of a second, radio because they arrive as radio waves, and bursts because they erupt and are gone. Fast radio bursts. And having named them, we began, at last, to find more. First they trickled in, one at a time, each one precious, each one argued over. But as new telescopes were built specifically to watch for them, telescopes designed to stare at enormous patches of sky at once and catch anything that flickered, the trickle became a flood. And what that flood revealed was almost harder to believe than the flashes themselves. These bursts were not rare freak events happening once in a generation. They were happening constantly, all the time, all over the sky. Our best estimates now suggest that somewhere in the observable universe, a fast radio burst goes off hundreds, perhaps many hundreds of times every single day. Some estimates run higher still, into the thousands per day across the whole sky, when you account for all the faint ones we surely miss. Think of that as you lie there. In the time it takes you to drift from waking into sleep tonight, dozens of these titanic flashes will have fired somewhere out in the dark, each one a burst of energy that dwarfs anything our world has ever known, each one lasting 1,000th of a second, most of them from galaxies whose light left before the Earth was even formed. The universe is quietly flickering with them, a vast and silent field of flashes, and we have only just learned to see it at all. And so the mystery sharpened into a single, wonderful question. What could possibly make such a thing? What kind of event could pour out 3 days, or 30 years, of a star's whole light in a single millisecond, and do it hundreds of times a day, all across the cosmos? It was into that question that the Blitzar was born. A dying supramassive neutron star, ringing out one last note as it fell into a black hole, seemed to fit the flash almost perfectly. Blinding, enormous, and final. But before we can weigh whether the Blitzar is truly the answer, we have to understand how anyone measures these flashes at all. We have to sit for a long, calm while with the question that is really half of this whole story. How do we know any of this? How do we measure a thing that lasts 1,000th of a second and comes from the edge of the visible universe? So let us sit with that question, the way you might sit by a window watching rain, in no hurry for it to stop. How do we measure a flash that lasts 1,000th of a second and was born at the edge of the visible universe? It seems almost impossible when you say it plainly. And yet, piece by patient piece, people have found ways. The measuring is not a footnote to this story. The measuring is half the wonder. I would even say the cleverness we have brought to catching these flashes is as beautiful as the flashes themselves. Start with the simplest tool, the thing that catches the flash at all. A radio telescope. Now, when you hear the word telescope, you probably picture a long tube with glass lenses, something you raise to your eye to make the distant stars look near. A radio telescope is nothing like that. It has no eyepiece, and you could stand and stare into it all night and see nothing. It is usually a great curved dish of metal, like an enormous shallow bowl tipped up toward the sky. And what it gathers is not the light your eyes can see, but radio waves, that long, calm, invisible cousin of ordinary light. Here is a thing worth resting on for a moment. Light and radio waves are the very same kind of thing. Both are waves of pure energy, ripples in the electric and magnetic fields that fill all of space, both traveling at the one great speed, the speed of light. The only difference between them is the length of the ripple. The light your eyes can see has ripples so small that thousands of them would fit across the width of a hair. Radio waves have ripples far longer, sometimes as long as your hand, sometimes as long as a room, sometimes longer still. Your eyes simply are not built to sense ripples that long, any more than your ears are built to hear the deepest rumble of the earth. The ripples are there, all around you, all the time, streaming down from the sky. A radio telescope is simply an eye, built to see the colors we were born blind to. The great curved dish does one simple thing. It gathers those long, faint ripples over its whole wide surface and reflects them all inward to a single point, the way a curved mirror gathers sunlight to a bright spot. Point sits a sensitive receiver that feels the ripples arrive and turns them into a signal a machine can record. The bigger the dish, the more ripples it can gather, and so the fainter the whisper it can hear. This is why the great radio dishes are so enormous, some of them wider than a football field, a few of them wider still. When you are trying to catch a signal no stronger than a mobile phone left on the moon, you need to gather every scrap of it you can. But a single dish, for all its size, has a hard problem when it comes to these flashes. A dish points at one small patch of sky at a time, the way you might point a flashlight at one spot on a dark wall. And a fast radio burst can come from anywhere at any moment without warning, and it is over in 1,000th of a second. If your dish happens to be pointed somewhere else when the flash fires, and it almost always is, you miss it entirely. Trying to catch these bursts with a single narrow dish is like trying to catch raindrops on the head of a pin. You will catch one now and then by pure luck, but you will miss 10,000 for every one you catch. This is exactly why, for years, we had only a handful of these flashes, each one found by accident, each one argued over. So people built something cleverer. Instead of one dish staring at one small spot, they built instruments that could watch enormous swaths of the sky all at once. The trick was to stop thinking about a single bowl and start thinking about many antennas working together. If you spread out a great many simpler antennas across a field, and you record what every one of them hears, and then you combine all those recordings with careful mathematics inside a computer, you can reconstruct a view of a huge stretch of sky at the same time. You are no longer pointing a flashlight at one spot on the wall. You are lighting up half the wall at once and watching all of it for the faintest flicker. One of the most successful of these was built in a quiet valley, a set of long half-pipe-shaped troughs of metal wire lying open to the sky, never moving, never pointing, simply drinking in everything that passes overhead as the earth turns beneath the stars. It has no moving parts to aim. It just watches a broad band of the whole sky, night and day, and lets the turning of the earth carry new sky through its view. Behind it sits a bank of computers doing an almost unimaginable amount of arithmetic every second, sifting the flood of radio noise for the telltale shape of a burst. This one instrument changed everything. Where once we had a handful of flashes found by luck, this and machines like it began finding them by the hundreds and then the thousands. In its very first year of listening, it caught more than 500 of these bursts, more than everyone on Earth had found in all the years before it combined. Today the catalogue runs into the thousands, and it grows almost every night. Now we can catch the flashes. Catching a flash is only the beginning. Once you have one, a whole new set of questions opens, and every one of them needs a different clever trick to answer. How far away was it? How much energy did it truly release? What kind of thing made it? And the deepest question of all for our story, did it flash only once and fall silent, or did it flash again? Let us take these one at a time, slowly, because each answer is a small marvel. We have already met the first trick, the one that measures distance from the flash itself. Remember the electron fog that fills the space between the stars, the thin haze that drags the low notes of the flash, a little behind the high ones. Remember how the size of that drag, the dispersion measure, tells us roughly how much fog the flash crossed, and so roughly how far it came. This was the very fingerprint that first proved the Lorimer Burst came from far outside our galaxy. For a long time it was almost all we had to go on. We could look at how smeared a flash was and say, this one is far, this one is farther, this one crossed a truly staggering gulf of fog to reach us. It was a rough measuring tape, but it was ours, and it worked. But a rough tape was not enough, because that same electron fog does not lie evenly across space. Some directions hold more fog than others. A flash might have crossed a crowded, dusty region and picked up extra drag without being especially far away, or it might have slipped through an unusually empty corridor and arrived less smeared than its true distance would suggest. To truly pin a flash down, we needed something better than the fog. We needed to find the exact place in the sky the flash came from, and then look and see what was sitting there. This is far harder than it sounds. A single dish, even a large one, can tell you only roughly which direction a flash arrived from, a broad patch of sky that might hold thousands of distant galaxies, any one of which could be the culprit. To do better, astronomers reach for one of the most elegant ideas in all of science. They use not one telescope, but several, spread far apart across the surface of the Earth, sometimes on different continents, all listening to the same flash at the same time. Because the telescopes sit in different places, the flash reaches each of them at a very slightly different instant, arriving a hair sooner at the nearer ones and a hair later at the farther ones. By comparing those tiny differences in arrival time, with clocks accurate beyond anything in daily life, astronomers can work backward and pin down the direction of the flash with astonishing precision, far finer than any single dish could ever manage. It is as if the whole planet became one enormous telescope, its separate ears spread thousands of miles apart, all straining toward the same faint sound. And when they do this, when they narrow the arrival of a flash down to a single tiny point on the sky, they can finally turn an ordinary light telescope toward that exact spot and ask the simplest question of all. What is there? And more often now, the answer is a galaxy. A faint, distant smudge of 100 billion stars, so far away it is barely a speck in even our finest instruments, sitting precisely where the flash was born. To find the home galaxy of a flash is a quiet triumph. It means we are no longer guessing from the fog alone. We can see the very island of stars the flash came from. And once we have found the home galaxy, we can measure its true distance in a way that owes nothing to the electron fog. For this, astronomers use another gift written into light itself, one you already know from everyday life, even if you have never named it. You know how the whistle of a passing train drops in pitch as it rushes away from you, the sound stretching lower and lower as it recedes. Light does the very same thing. When a source of light is racing away from us, its waves are stretched out, and stretching light makes it redder, shifting it toward the long, calm end of the spectrum. We call this redshift, the reddening of light from something rushing away. And here is the deep and strange fact that makes it so useful. Our universe is expanding. Every distant galaxy is being carried away from us as the space between us all quietly stretches, and the farther a galaxy is, the faster it recedes, and so the more its light is reddened. This means the amount of redshift in a galaxy's light is a direct measure of its distance. Measure how much the light of the home galaxy has been stretched toward red, and you know, cleanly and independently, how far away it truly sits. No electron fog required. And when astronomers did this for the home galaxies of these flashes, the distances that came back were breathtaking. Hundreds of millions of light years. Then billions. Then more billions still. One flash traced to its home turned out to have set out on its journey some 8 billion years ago, when the universe itself was barely half its present age, long before the sun and the earth had formed, long before there was anyone here to wonder about anything at all. Now put those two measurements together, the true distance from the reddening of the home galaxy and the faintness of the flash as it arrived at our dish. If you know exactly how faint a light looks, and you know exactly how far away it is, then simple reasoning tells you how bright it truly was at the source. Candle across a room and a bonfire on a distant hill can look equally dim to your eye, but if you know the distance to each, you can work out that one is a candle and the other a blaze. Do this for a fast radio burst, and the answer is the staggering figure we met before. To be that faint after crossing billions of light years, the flash must have released, in its single thousandth of a second, as much energy as the sun pours out across days, and in the most extreme cases across many years. This is how we know. Not by guessing, not by hoping, but by measuring the distance one way and the faintness another, and letting the two together force the truth into the open. Let us stay with the numbers for a while, because they are so large that no single telling of them can really land, and the only honest way to feel them is to come at them again and again, from one side and then another, the way you might walk slowly around something enormous in the dark, reaching out to touch a different part of it each time. Restating the scale is not repeating myself. It is the only way the mind can climb something this size, one handhold at a time. Begin with the length of the flash. 1,000th of a second. That is the whole life of a Blitzar signal, from the first stirring to the last fading. 1,000th of a second is a span so short that nothing in your ordinary day comes anywhere near it. The blink of an eye, which we speak of as the very picture of quickness, takes around 1/3 of a second, which means you could fit a few hundred Blitzar flashes inside a single blink and still have room to spare. A hummingbird's wing, beating dozens of times a second, is slow and lumbering next to it. In the time it takes the fastest sound you can make with your mouth to leave your lips, the flash has already come and gone, over and done, sealed forever. It is, very nearly, the universe expressed as an instant. And into that instant is poured an amount of energy that has no comfortable comparison anywhere in human life. Think again of our sun, that steady golden fire that has warmed every summer of every life that has ever been lived. In one single second, the sun releases more energy than all of humanity has produced in every furnace and engine and power plant across our entire history. That is 1 second of one ordinary star. Now stretch that to 3 whole days. 3 days of that ceaseless outpouring gathered up into one pile. Pile of energy, give or take, is what a fast radio burst can release, and it releases it not across 3 days, but in that single thousandth of a second. 3 days of a star's whole life, spent faster than you can blink. If that does not quite reach you, take the most extreme flash we have measured, and stretch the comparison further still. Not 3 days of sunlight, but 30 years. Every drop of light and heat and energy the sun sheds across 3 entire decades, enough to warm the world through 30 winters and 30 summers, enough to grow 30 years of harvests and melt 30 years of snow, all of it released at once, in a flash briefer than a heartbeat, from a single point somewhere out in the dark. 30 years of a star, in a thousandth of a second. The mind simply refuses it at first. That refusal is the correct response. It means you are beginning to feel the true size of the thing. Here is another way to hold it. For the length of that flash, the source shines brighter in radio light than every star in its entire home galaxy combined. Brighter than one star. Brighter than 1,000 stars. Brighter than 100 billion of them, all shining together, the whole glittering wheel of a galaxy outdone by a single point for 1,000th of a second. Imagine standing far outside a great spiral of 100 billion suns, that vast slow pinwheel of light, and seeing one tiny spark at its edge flare up brighter than the whole wheel, and then vanish before you could even turn your head toward it. That is the flash. That is the scale of what may be a single dying star saying goodbye. And now hold, against all that violence, the gentleness of what actually reaches us. After the flash has crossed its ocean of space, spreading and thinning and fading across hundreds of millions or billions of light years, what arrives at our great metal dishes is one of the faintest signals we know how to catch. People who work with these things reach for a homely comparison to describe it. They say the flash, by the time it gets here, is no stronger than the signal from a mobile phone lying on the surface of the moon. A phone on the moon, whispering across the 250,000 miles of empty space to a receiver on Earth. That faint. That is the murmur we are straining to hear. The most violent flash the cosmos allows, arriving as the softest of whispers, because it has come so unthinkably far. Sit in the strangeness of that pairing for a moment, because it holds something worth carrying into sleep. The same event is, at once, one of the loudest things in all creation and one of the quietest we have ever measured. Loud beyond reckoning at its birth. A whisper by the time it finds us. and the only reason it has softened so much is the sheer distance it crossed, which is really just another way of saying the sheer size of the universe it had to travel through. Faintness is a measure of the vastness. The whisper is the voice of the gulf. And that gulf is worth dwelling on, because the distances here are as staggering as the energies. A light year, first of all, is not a measure of time, but of distance. It is how far light travels in 1 year, moving at the greatest speed there is, some 6 trillion miles. Light is so fast that it crosses from the sun to the earth in about 8 minutes, and crosses from one side of our whole world to the other in less than the time it takes to draw a breath. And yet, moving at that impossible speed, without ever slowing, without ever resting, it takes a full year to cross a single light year. Now consider that many of these flashes were born not 1 light year away, not 1,000, not 1,000,000, but billions of light years away. Let that distance become a length of time, because that is the truest way to feel it. When you catch a flash that set out 8 billion years ago, you are not seeing something that happened recently and far away. You are seeing something that happened 8 billion years ago and has only just now arrived. The light left its source before the sun existed. Before the earth existed. Before there was a single living thing anywhere in the story that would one day lead to you. That flash has been traveling, crossing the widening dark the entire time. Crossed while the earth was still gathering itself out of dust. Crossed while the first faint life stirred in ancient seas. Crossed while the great slow parade of living things unfolded, while forests rose and fell, while ice came and went, while the first people looked up and wondered. And it kept crossing, unbothered by any of it, until one particular night, on one small world, it slipped at last into a waiting dish, and a machine noticed, and we finally knew it was there. You were alive for the arrival. That is the almost unbearable tenderness of it. Out of all the billions of years that Flash was in flight, out of all the ages it could have arrived, it happened to complete its journey in the brief sliver of time when there were beings here who had built the instruments to catch it and the curiosity to care. 1,000th of a second of light, born before the earth, arriving in the one narrow window of history when someone could receive it. If that does not feel like a kind of meeting across an impossible distance, I do not know what would. And here is the final turn of the numbers, the one that changes the whole feeling of the sky above you. These flashes are not rare. For a long time we thought they must be, because we caught so few. But that was only because we were nearly blind to them. Now that we have built instruments that can watch great swaths of the sky at once, we have learned the truth. Somewhere in the reachable universe, one of these titanic flashes fires hundreds of times a day, by some careful estimates many hundreds, and when you account for all the faint ones that surely slip past us, perhaps thousands every single day, the sky is quietly seething with them. This very moment, as you lie here breathing slowly, flashes are firing all across the dark, each one a burst of energy beyond anything our world has ever produced, each one lasting 1,000th of a second, each one from a galaxy so far away its light is older than our sun. You cannot see them. Your eyes were never built for radio light, and even if they were, most of these flashes are far too faint and far too brief for any eye to catch. They are there, all the same, above the roof, beyond the clouds, past the moon and the planets and the nearest stars, out in the great dark field of galaxies, flickering on and off like the faintest imaginable fireflies scattered across the whole width of creation. The universe you are drifting off beneath is not a still and silent thing. It is alive with these brief brilliant deaths, or these brief brilliant flares, whatever they turn out to be, going off constantly, softly, unseen, in every direction you could ever point. And we have only just, in the span of a single human lifetime, learned to notice them at all. Which brings us back, gently, to the question we came here to sit with. All these flashes, hundreds or thousands a day, pouring out days or decades of a star's whole light in 1,000th of a second from every corner of the sky. What makes them? Is each one truly a supramassive neutron star ringing out its last note as it falls into a black hole, a Blitzar, as Falcke and Rezzolla imagined? Or is something else at work? To weigh that, we have to notice one crucial thing about these flashes, a single clue that splits them cleanly into two families, and that tells us the Blitzar, whatever else it may be, cannot be the whole story. Let me return once more to the sheer precision of how we catch these things, because it is a marvel worth resting in, and because coming back to the measuring again and again is part of how the wonder settles into the mind. When a flash arrives at our instruments, it does not simply announce itself as a lump of brightness. It arrives with a shape, a swift downward sweep from high notes to low, and reading that shape correctly requires clocks of almost unbelievable accuracy. To measure how far the low notes lag behind the high ones, and to do it well enough to weigh the fog of an entire universe, we need to time the arrival of a signal to within tiny fractions of a single 1,000th of a second. Clocks that do this are among the most precise objects ever built, so steady that they would not gain or lose a second in millions of years. We have built, in other words, timekeepers accurate beyond any human need, purely so that we can read the faint smeared whisper of a dying star correctly. There is something touching in that we would go to such lengths, build such exquisite instruments, all to hear a flash a little more clearly. And think of what the shape of the flash actually tells us when we read it with those clocks. The downward sweep, the slide from high pitch to low, is not just a curiosity. Its exact steepness reveals how much electron fog the flash crossed, and so how far it travelled, and so, once we have found its home galaxy, how much of the universe's hidden matter lies strewn along that particular line of sight. A single flash, read carefully, is a core sample drilled straight through billions of light-years of cosmos, telling us the density of the dark between here and there. We do not have to travel that distance to measure it. The flash travelled it for us, and wrote the report in the shape of its own arrival, and all we had to do was build a clock steady enough to read the writing. There is another quality of these flashes worth dwelling on, because it is one of the deepest clues to what makes them, and it is a strange and beautiful thing in itself. The radio light of a fast radio burst is coherent. That word means something precise and remarkable. In ordinary light, from the sun or a lamp or a glowing coal, the countless little waves of light are all out of step with one another, each doing its own thing, a jumble of ripples with no shared rhythm. But in a coherent burst, the waves march together, in step, all rising and falling as one, like a vast crowd, all clapping in perfect unison, rather than a scattered patter of separate hands. Coherent light is enormously harder to make than ordinary light, and it points to something highly organized at the source, something that can marshal a staggering number of charged particles and make them all sing the very same note at the very same instant. That is exactly what the snapping magnetic field of a Blitzar would do, driving the particles outward in one coordinated pulse. And it is exactly what a magnetar's violently reorganizing field could do as well. The coherence does not, by itself, tell us which, but it tells us that whatever makes these flashes is not a mere explosion. It is something orchestrated, something that imposes an astonishing order on matter for one brief shining instant. Come back once more to the scale from yet another angle, because I never tire of turning it over, and I hope you do not either. We have said that a flash can release, in 1,000th of a second, as much energy as the sun pours out in 3 days, and in the most extreme cases, as much as it pours out in 30 years. Let me anchor that in something you can almost hold. The sun, every second, converts about 4 million tons of its own substance into pure energy, 4 million tons vanishing into light every single second, and has done so for over 4 billion years. Fast radio burst, in its brief life, can rival days or years of that ceaseless transformation. To match the most powerful ones, you would have to gather up 30 years of the sun, turning millions of tons a second into light, and release the whole sum in less time than a housefly's wing beat. There is no engine in human hands, no bomb, no reactor, no power plant that comes within a vanishing fraction of such a thing. And yet the universe does it casually, hundreds of times a day, in galaxies whose names we will never know. And still, by the time all that fury reaches us, it is the faintest of murmurs, no stronger than a phone signal whispering across the 250,000 miles from the moon. I keep returning to that pairing because it holds the whole feeling of this subject in a single image. Unimaginable violence at the source. The softest possible whisper at our end. And the only thing standing between the two is distance, plain distance, the sheer width of the cosmos the flash had to cross. When you feel how faint the arriving signal is, you are feeling, directly, how vast the universe is. The quietness is the size. The whisper is the measure of the gulf. Every faint flash we catch is the universe telling us, gently in the only language it has, just how far away everything truly is. So the next time the numbers threaten to overwhelm you, and they will, because they are genuinely overwhelming, come back to the measuring, the way we keep coming back to it tonight. Come back to the steady clocks, and the downward sweep, and the coherent waves marching in step, and the faint arriving whisper that is really a shout from across creation. The measuring is how we tamed the enormity. It is how we took something that lasts 1,000th of a second and comes from billions of light years away, something that should be utterly beyond our reach, and made it into a thing we can catch and weigh and read and wonder about safely from the warmth of our own small world. The universe is vast beyond feeling, but we are clever and patient, and we have built instruments delicate enough to hold its faintest whispers. That is a comforting thing to know, lying here in the dark. However large the cosmos grows in your imagination tonight, remember that we have found ways to measure it, gently, one flash at a time. And there is peace in that. There is real peace in being small and knowing it, and having found, even so, ways to listen to the whole vast thing. Clue is this. Some of these flashes happen once, and only once, and are never heard from again. And some of them repeat. For a long time, every fast radio burst we knew was a one-time event. A flash would arrive, bright and brief, and then the sky where it came from would fall silent, and no matter how long or how carefully we watched that spot afterward, nothing more would ever come. This fit the Blitzar idea beautifully, and you can already see why. A Blitzar destroys the very thing that made it. The supramassive neutron star falls into a black hole and is gone. It cannot flash again, because there is nothing left to flash. Once the note is struck, the bell is swallowed. A Blitzar is, by its very nature, a single event. One flash, then a black hole, then eternal silence. So a flash that comes once and never returns is exactly what a Blitzar should look like. For a while then, the picture seemed clean. Fast radio bursts came once, Blitzars come once. Perhaps every fast radio burst was a supermassive neutron star dying. It was a satisfying thought, tidy and complete. Nature, as it so often does, was keeping a complication in reserve. Because in time, watching one particular flash's home patch of sky, astronomers saw the impossible thing. It flashed again. The source was one we came to know as the first repeater. It had first been caught flashing in the year 2012 using the great dish at Arecibo, that enormous bowl set into a green valley. At first it was just one more flash among the growing collection, nothing to mark it out. But then, in the years that followed, that same exact spot in the sky flashed again, and again, and again. Not on any schedule, not with any rhythm you could set a clock by, but unmistakably, over and over, from the very same source. Sometimes it would fall quiet for months. Sometimes it would fire off many bursts in a single evening, one after another, as if it could hardly hold them in. Coming back. And a source that keeps coming back, cannot possibly be a Blitzar, because whatever is making these repeating flashes is still there after each one. It survives. It is not destroyed. It reloads and fires again. This single discovery split the whole field in two, cleanly and permanently. There are flashes that happen once, which we call the one-offs, or the non-repeaters. And there are flashes that come back over and over from the same spot, which we call the repeaters. And these two families almost certainly cannot both be made by the same kind of engine, because no single mechanism can be at once a thing that destroys itself in one flash and a thing that survives to flash 1,000 times. The very idea contradicts itself. So there must be at least two different kinds of maker out there in the dark, two different cosmic engines that happen to produce a similar looking flash of radio light. And here is what that means for our Blitzar, told plainly and gently, because honesty is the kindest thing I can offer you tonight. The Blitzar, if it exists at all, can only ever explain the one-offs. It can never explain the repeaters, not even in principle, because a repeater by definition is a source that lives on, and a Blitzar by definition is a source that dies. The moment we found repeaters, the Blitzar's territory shrank. Whatever else is true, most of the sky's flashes now had to have some other cause, at least the ones that come back. The Blitzar went, in that instant, from a candidate explanation for all fast radio bursts to a candidate explanation for only a portion of them, the ones that flash once and are gone. This does not kill the idea. It is worth being careful here, because it would be easy to swing too far. The existence of repeaters does not prove that the one-offs are Blitzars. It only leaves the door open for them. It is entirely possible, and many scientists think it likely, that even the one-time flashes we see are simply repeaters that we have not yet caught repeating, sources that flash rarely enough that we happen to catch them only once and gave up watching too soon. Absence of a second flash is not proof that a second flash will never come. Perhaps if we watched every one-off source patiently enough, for long enough, some of them would eventually speak again, and the whole clean split between one-offs and repeaters would blur. We simply do not yet know. But let us dwell for a moment on that first repeater, because when astronomers turned the full force of their instruments upon it, it told us something wonderful, and something that pointed away from the Blitzar rather than toward it. Remember the trick of using many telescopes across the Earth at once to pin down exactly where a flash comes from. They did this for the repeater, and because it kept flashing, they had many chances to get it right, and they narrowed its position down to a tiny point. And then they turned ordinary telescopes to that point and looked to see what was there. What they found was a small, dim, faraway galaxy, a little smudge of a place, far smaller than our own great spiral, a modest dwarf galaxy of the kind that dots the universe in enormous numbers. And sitting right at the spot of the flashes in that little galaxy was something else. A steady, persistent source of radio waves, glowing on, not flashing but shining continuously, right where the bursts were coming from. This was a profound clue. It meant that whatever was making the repeating flashes was sitting inside or right beside some energetic, active object that glowed all the time. Flashes were not coming from a lonely dying star in an empty patch of sky. They were coming from a busy, powered place, a spot where something was constantly pouring out energy. That persistent glow does not fit a blitzar at all. A blitzar is a single, silent collapse. Does not leave behind a steady beacon shining for years. But it fits very well with a different kind of engine, one that has slowly come to the front of scientists' minds as the most likely maker of at least the repeating flashes. And that engine is a particular, extreme kind of neutron star, one we have not yet met tonight, though it is a close cousin of everything we have been discussing. It is a neutron star with a magnetic field so violent, so far beyond anything else in nature, that it can crack its own surface and blast out flares of energy without ever destroying itself. We call it a magnetar. And it is time now to meet it, because it is the Blitzar's chief rival, and understanding it is the only way to understand honestly where this whole mystery truly stands today. But before we turn to the magnetar, let me leave you with the shape of where we have arrived, because it is a restful place to pause. We came in with a single beautiful idea, the Blitzar, a supramassive neutron star ringing out one last note as it falls into a black hole. We have followed that idea down to its roots, through the death of giant stars, through the birth of neutron stars, through the strange limit that lets some of them cheat gravity by spinning, through the snapping of a magnetic field as a star vanishes behind an event horizon. And then we let the sky complicate the story, as it always does, by showing us that some of these flashes come back over and over and so cannot be dying stars at all. This is how understanding actually grows. Not in a straight, clean line from ignorance to certainty, but in this gentler, more honest way, an idea proposed, tested against the sky, narrowed, qualified, held up beside its rivals, alive but no longer alone. There is a deep calm in that, if you let yourself feel it. The universe is under no obligation to give us tidy answers, and it rarely does. What it gives us instead is a slow, patient conversation, a back and forth between what we imagine and what we observe, stretching across lifetimes never quite finished. And we get to be here for a little while, listening in on that conversation, catching a few flashes, wondering what they mean. That is enough. That is more than enough. Now let us meet the magnetar and see how the conversation stands tonight. A magnetar is a neutron star, born the same way all neutron stars are born, from the collapsing core of a dying giant. But a magnetar is set apart by one overwhelming feature. Its magnetic field is the strongest thing we know of anywhere in the universe. Every neutron star has a fierce magnetic field, far beyond anything we can make on Earth. A magnetar's field is stronger still, by 1,000 times, sometimes more. It is a field so powerful that the numbers describing it stop meaning anything to ordinary intuition. If a magnetar drifted to within half the distance of the moon, its magnetic field alone would scramble every credit card and wipe every hard drive on the whole of the Earth. If you could somehow survive being anywhere near one, the field would distort the very atoms of your body, stretching them thin, because atoms simply cannot keep their normal shape in a field that strong. It is a level of magnetism that borders on the unthinkable. Where does such a field come from? We are not entirely certain, and that honest uncertainty is worth naming. The leading idea is that when certain neutron stars are born spinning fast enough, in just the right way, the churning of their fluid interior in those first violent seconds acts like a dynamo run wild, winding the magnetic field up to staggering strength and then locking it in as the star settles. However it happens, the result is a star wrapped in a field so intense that the field itself becomes the most important thing about the star. The field holds more energy than the star's spin does. And that stored magnetic energy is a reservoir that can be tapped again and again without ever destroying the star. This is the crucial difference from a blitzar. A blitzar spends everything at once. Collapses, it flashes, it dies. A magnetar sips from its enormous magnetic reserve. Now and then the strain in that titanic field grows too great, and the star's rigid crust cracks, or the field lines suddenly rearrange themselves into a lower, calmer state, releasing a burst of energy in the process, a bit like an earthquake in the star's skin or a sudden snap of a twisted magnetic rope. And each such event can fling out a pulse of radiation. But the star survives. The crust settles. The field, though it has shed some energy, is still enormous. And so the magnetar can flare again another day, another year. It reloads. It repeats. Which is exactly the behavior we see in the repeating flashes. For years, the magnetar was a suspect in the fast radio burst mystery, but only a suspect, argued for on paper, never caught in the act. All the fast radio bursts we knew came from far outside our galaxy, from those distant dwarf smudges billions of light years away, far too remote for us to ever see the individual star behind the flash. We could reason about what might be making them, but we could not point at one and say, "There, that star, that is the maker." The distances forbade it. And then, in the spring of the year 2020, the universe finally handed us the thing we had been waiting for. Fast radio burst that went off inside our own galaxy, close enough to see the culprit plainly. The source was a magnetar already known to us, a violent little star catalogued years before, sitting some 30,000 light-years away, well within our own Milky Way, in the direction of a small constellation called the Falcke. It had been restless for weeks, giving off flares of high-energy light, the kind of behavior magnetars are known for. Astronomers were watching it closely. And then, on the 28th of April, in the year 2020, it did something no magnetar had ever been caught doing before. It released a burst of radio waves so bright, so brief, so exactly like the fast radio bursts we had been chasing across the cosmos, that when the measurements came in, there was a kind of collective hell breath among the scientists who study these things. Two separate instruments caught it, on opposite approaches, each confirming the other. One was the great sky-watching array we spoke of earlier, the one that stares at broad swaths of the heavens at once. The other was a smaller, scrappier set of simple antennas spread across the southwestern United States, built precisely to catch bright bursts. Both recorded the same thing at the same instant. A flash from the magnetar, lasting only about 1,000th of a second, carrying a titanic amount of energy for something inside our own galaxy, with the very same fingerprints as the distant fast radio bursts. And in a further gift, the radio flash lined up in time with a burst of high-energy light from the same star, tying the flash directly to the magnetar's known behavior. There was no room to doubt what had made it. We had seen the maker with our own instruments. A magnetar, right here in our galaxy, had produced a fast radio burst. This was one of the great turning points in the whole story. For the first time we had caught a fast radio burst in the act and could say, with confidence, this one was made by a magnetar. Did not solve the entire mystery. The flash from our galaxy's magnetar, though enormous by local standards, was still fainter than the most powerful of the distant bursts, so it did not prove that magnetars can make every kind of flash we see. But it proved, beyond serious doubt, that magnetars can make at least some fast radio bursts. The suspect had confessed. The engine we had reasoned about on paper had shown itself to be real. And overnight the magnetar went from one idea among many to the leading explanation for the fast radio burst mystery, or at least for a great many of the flashes. And this is where I must be most honest with you, because the whole point of walking through this together is to leave you with a true picture, not a tidy one. As things stand tonight, the Blitzar is not the front runner. The magnetar is. When astronomers today are asked what makes fast radio bursts, most of them will point first to magnetars, because we have actually caught one doing it, and because the repeating flashes fit a surviving, reloading source so much better than they fit a dying one. The Blitzar remains a real, respectable, carefully reasoned idea. But it is no longer at the centre of the table. It has moved to the edge, one hypothesis among several, still standing, still possible, but no longer the first name spoken. I want to say clearly what the Blitzar still might be, because a good idea narrowed is not a good idea defeated. The Blitzar could still be the true maker of some fraction of the one-time flashes, the ones that come once and never return. There is nothing yet that rules this out. Somewhere out there, supramassive neutron stars really do exist, at least briefly, and they really must collapse into black holes when their spin runs down, and that collapse really should snap their magnetic fields loose in the way Falcke and Rezzolla described. Physics of it is sound. The question is not whether blitzars can happen. The question is whether they happen often enough and brightly enough to account for any of the flashes we actually see, or whether they are so rare that they hide entirely beneath the far more common magnetar flares. That question is still open. May stay open for a long time. There is something I find deeply restful in holding an idea this way, neither clutching it as certain nor throwing it away as false, but simply letting it rest in its true place as a possibility, weighed honestly against its rivals. So much of the noise of the world comes from people insisting on certainty they do not have. The sky teaches a gentler habit. It says, here is something that might be true. Here is what would have to be the case for it to be true. Here is the evidence we have, and here is what it does and does not tell us. And here, most importantly, is the honest admission of what we still do not know. There is no shame in that admission. It is the very heart of how we come to know anything at all. The Blitzar is a beautiful maybe, and a beautiful maybe held with an open hand is a fine thing to fall asleep thinking about. Now, there is one more thread to follow before we let the science soften into reflection, and it is perhaps the most wonderful of all, because it ties the Blitzar to a whole new way of listening to the universe, a way we possessed only in dreams until very recently. If a supramassive neutron star really does form and then collapse, the flash of radio light might not be the only signal it sends. The collapse itself, the sudden falling of all that mass, should shake the very fabric of space and time and send out ripples we have finally, in our own lifetimes, learned to feel. To understand that, we have to talk about gravitational waves and about one particular event a few years ago when two neutron stars met, merged, and left behind something that may have lived, briefly, on the very knife edge we have been describing all night. Everything we have talked about tonight we learned by catching light. Radio light, mostly, that long, calm cousin of the light our eyes can see. And for the whole of human history, until almost this very moment, light was the only messenger we had. Every single thing anyone had ever known about the sky, from the first shepherd who named a star to the astronomer who found the Lorimer Burst, came to us as light of one kind or another, falling out of the dark onto an eye or a dish or a photographic plate. We were, for all our cleverness, creatures who could only see. And then, just a few years ago, we gained a second sense. We learned to feel. To understand what we learned to feel, come back to Einstein's great picture of gravity, the one that says gravity is not really a force reaching across space, but the bending of space and time themselves. In that picture, space is not an empty nothing, a blank stage on which things happen. Space is more like a vast, taut fabric, and everything that has mass presses into it and curves it, the way a heavy stone presses into a stretched sheet. The sun makes a great dimple in that fabric, and the earth rolls around the rim of that dimple, and that rolling is what we feel as the sun's gravity. It is a strange and beautiful idea, and it has passed every test we have ever devised. Now here is the part that took 100 years to confirm. If space is a fabric that can be bent, then it can also be shaken. If you take something very heavy and move it violently, you should send ripples spreading out through the fabric of space itself, waves of stretching and squeezing that travel outward at the speed of light, making the very distances between things grow a little longer and then a little shorter as they pass. Einstein predicted these ripples and then doubted whether they could ever possibly be detected, because they would be so faint by the time they reached us as to seem beyond any hope of measuring. We call them gravitational waves. And for 100 years they remained only a prediction on paper, too subtle to catch. The trouble is that these waves stretch and squeeze space by an amount so small it defies belief. When a strong gravitational wave passes through the Earth, it changes the length of, say, a stretch of ground a few miles long by less than the width of a single proton, less than a fraction of the size of one atom's tiny heart. To feel a change that small, we had to build some of the most precise instruments ever made by human hands, enormous L-shaped rulers with arms miles long, using beams of laser light bouncing back and forth to compare the lengths of the two arms with a delicacy beyond anything that had ever been attempted. If one arm stretches by even that unimaginably tiny amount while the other does not, the instrument can feel it. It is, in truth, less an eye than an ear. We built ears for the trembling of space. And they worked. In our own time, these instruments began to feel the ripples from the most violent events in the cosmos. The collisions of black holes and neutron stars far out in the dark, events that shake the fabric of space hard enough that the tremor is still just barely feelable after crossing the entire gulf between galaxies. We had gained a second sense. We could no longer only see the universe. We could feel it shudder. And then came the event that ties this whole night together. In the late summer of the year 2017, both the gravitational wave instruments and the ordinary light telescopes caught the same thing at the same time, for the first time ever. Two neutron stars circling each other in a distant galaxy, spiraling inward as they shed their energy into gravitational waves, closer and closer, faster and faster, until at last they met and merged. The instruments felt the ripples of that final inward spiral, a rising tremor in the fabric of space, climbing in pitch as the two stars whirled together in their last seconds. And then, moments later, telescopes around the world swung toward the spot and caught the light of the collision, the glow of the debris flung out by the smash-up. For the first time, we had both felt and seen the same cosmic event. We had heard the universe shudder and then turned to watch the flash. It was a new kind of astronomy, born in a single night. But here is what makes that event matter so much to our story of the Blitzar. When two neutron stars merge, the great question is, what is left behind? Two stars together carry a great deal of mass, and mass, as we have seen all night, wants to become a black hole if there is enough of it, and nothing to hold it up. So one possibility was that the merger simply made a black hole at once, in an instant, the moment the two stars touched. But there was another possibility, and it is the one that should make you sit up gently in the dark. The other possibility was that the merger did not make a black hole right away. The other possibility was that it made, for a little while, a single spinning star, too heavy to stand still, held up only by the ferocious spin it had gathered from the whirling of its two parents. In other words, it made a supramassive neutron star, the very thing a Blitzar needs. And a supramassive neutron star, as we know so well by now, cannot last. It spins down, it loses its borrowed strength, and it collapses into a black hole. If that is what happened after this merger, then somewhere in the minutes or hours or days after the collision, that leftover star would have crossed its limit and fallen, and in falling it should have snapped its magnetic field loose and wrung out, and it should have sent a final shudder through the fabric of space as all its mass dropped into the new black hole. A Blitzar, in other words, born from a merger we actually felt and saw. Did that happen? Here again I must give you the honest answer, which is that we are not sure, and the uncertainty is itself part of the wonder. The evidence from that famous merger is tangled and much debated. Some of what astronomers saw in the days afterward, the particular way the glow of the debris brightened and faded, hints that the merger really did leave behind a heavy spinning star that survived for a time before collapsing, rather than making a black hole instantly. Other scientists read the same evidence differently and think the collapse came quickly. We did not manage to catch a clear final shudder of the leftover star falling in, partly because our instruments were not perfectly placed to feel it, and so the crucial last moment slipped past us just out of reach. What we can say is that this event showed us, for real, in the sky, the very setup the Blitzar idea requires. Two neutron stars really can merge into a single overweight spinning star that is destined to fall. Whether that particular star fell in the exact way the Blitzar picture describes, we cannot yet say. The stage was set, and we watched it being set, and that alone is a marvel. Think of what this means for the future, and let it be a hopeful thought to rest on. We now have two ways of sensing the universe working together: the seeing and the feeling, light and gravity, each catching what the other misses. If a true Blitzar ever happens close enough and clearly enough, we might one day catch it with both senses at once. We might feel the shudder of the collapse in our great trembling rulers, and in the very same instant, or a heartbeat later, catch the flash of radio light in our great listening dishes, and finally, at long last, tie the flash to the fall beyond any doubt. We might actually watch a star become a black hole, feeling the ground of space give way beneath it, and hearing its last radio cry, and know for certain that the beautiful idea Falcke and Rezzolla wrote down was true, at least sometimes, at least somewhere. We are not there yet, but we have built the senses. We are listening. And the universe, hundreds of times a day, is flashing. That is where the science stands tonight, as honestly as I can lay it out for you. A beautiful idea, narrowed but not defeated. A rival that has been caught in the act and now leads. A new pair of senses that may one day settle the matter for good. And a sky quietly seething with flashes we have only just learned to notice. It is a good place to leave the hard science and to let our thoughts drift outward from the flashes themselves toward the stranger and softer question of what any of it might mean for us, small and warm and awake in the dark, wondering. Before we let the science soften entirely, I want to share one more thing these flashes do for us, because it turns the whole story on its head in the loveliest way. So far we have treated the fast radio burst as a mystery to be solved, a riddle whose answer we are still chasing. But even before we know for certain what makes them, these flashes have quietly become one of the most useful tools we have ever been handed for measuring the universe itself. The very thing that makes them so hard to explain, that long sweep of dispersion as they cross the electron fog, turns out to be a gift. 'Cause that fog is not just noise. That fog is the universe's own hidden matter, and the flashes passing through it weigh it for us. Let me explain gently, because it is one of the quiet triumphs of recent science. For a long time, astronomers had an embarrassing problem. When they added up all the ordinary matter the universe ought to contain, the atoms, the gas, all the everyday stuff that stars and planets and people are made from, and then went looking for it in the sky, a great deal of it was simply missing. The mysterious dark matter, which is a separate puzzle, but plain ordinary matter, the kind we understand. The books did not balance. About half of the ordinary matter that should exist could not be found. It was not in the stars, not in the glowing gas of galaxies, not anywhere we could easily see. It had gone missing, and no one could say for certain where. The suspicion was that this missing matter was spread out in the vast spaces between the galaxies, in thin, cold, dark wisps of gas strung across the emptiness, too faint and too diffuse to glow, too spread out to catch by any ordinary means. A cosmic fog, in other words, filling the gulfs between the islands of stars. But suspecting it is there and proving it are two different things, and for a long time we had no way to weigh a fog we could not see. And then we realized that the fast radio bursts had been weighing it for us all along. Remember what dispersion is. As a flash crosses space, the thin haze of electrons drags its low notes behind its high notes, and the size of that drag tells us exactly how many electrons the flash passed through on its way to us. But those electrons are the missing matter. That thin haze between the galaxies is precisely the lost ordinary matter we had been unable to find. So every fast radio burst, as it crosses the universe to reach us, is taking a census of all the hidden matter along its path, counting it up, and delivering the tally to us encoded in the shape of its own smear. The flash is a surveyor. It walks the whole distance from its source to our dish, tallying the invisible fog every step of the way, and hands us the count when it arrives. And when astronomers gathered enough of these flashes, from enough different distances and directions, and added up all the matter the flashes had counted, the missing matter appeared. The books balanced at last. The lost ordinary matter of the universe was found, right where it had been suspected to be, spread thin across the great gulfs between galaxies, and it was the fast radio bursts, those very flashes whose makers we still argue about, that found it. We do not yet know for certain what makes them. And yet, not knowing what they are, we have already used them to locate half the ordinary matter in creation. There is something almost funny in that, and something deeply hopeful too. A mystery can be useful before it is solved. A question can answer other questions while it waits for its own answer. Sit with the strangeness of that for a moment, because it is a beautiful thing to hold as you grow drowsy. Out in the dark, a star dies or a magnetar flares, we are not even sure which, and it sends out a flash of radio light. That flash crosses billions of light years, and all along the way it brushes through the thin invisible fog that fills the spaces between the galaxies, the lost matter of the cosmos, gathering a faint record of everything it passes. And at the end of that unimaginable journey, it delivers its record to a dish of metal on a small blue world, and the beings on that world read the record and finally learn where the missing half of their universe had been hiding all along. The flash did not mean to tell us anything. It simply crossed the fog and carried the news, because that is what light does. It carries the news of everything it touches. This is worth remembering whenever the not knowing starts to feel like a loss. We do not yet know whether the Blitzar is real. We do not yet know what makes most of these flashes. Look at everything we have already learned from them along the way. We have weighed the invisible matter of the universe. We have measured distances across billions of light years. We have confirmed that space between the galaxies is not empty, but softly filled. We have pinned down faraway dwarf galaxies we would never otherwise have noticed. We have caught a magnetar in our own galaxy in the act of flaring. Every one of these is a real, solid piece of knowledge, one from a mystery we have not yet cracked. The unsolved question has been generous. It has paid us in 12 currencies while withholding the one coin we came for. And more is coming, almost certainly, in your lifetime. The instruments are getting better. The catalogues are growing from thousands toward tens of thousands, and every new flash sharpens the picture. We are learning to map the fog of the universe in fine detail, to trace the great invisible web of matter along which the galaxies are strung like dew on a spider's thread. We are learning to use the flashes as beacons to probe the space they cross, turning each mystery into a lantern held up against the dark. Somewhere out there, right now, are the flashes that will finally settle whether Blitzars are real, whether some fraction of these bursts truly are supramassive neutron stars dying into black holes. Those flashes are already on their way. Some of them left their sources billions of years ago and are crossing the last stretch of space toward us, even as you lie here. We have only to keep listening. And we will. There is a patience in that thought that I find very restful. The answers are already in flight. We do not have to wrench them from the universe by force. We have only to build good instruments and point them at the sky and wait, and the light will arrive when it arrives, carrying whatever truth it has been carrying all along, indifferent to our impatience, faithful to its speed. The flash that will explain the Blitzar may arrive tomorrow, or in 10 years, or in 100, long after everyone alive tonight has gone to their rest. It does not matter. It is coming. The universe is under no obligation to hurry, and there is a deep peace in accepting that, in letting the great slow conversation between what we imagine and what we observe unfold at its own unhurried pace, across lifetimes, across centuries, never finished, always moving forward, one flash at a time. Now let the instruments rest for a while, and the numbers and the careful weighing of one idea against another. We have followed the Blitzar as far as honest science can take us tonight. We know what it would be, and how it would happen, and why it was dreamed up, and where it stands among its rivals, and all the wonderful things we have learned along the way while chasing it. What remains is softer, and in some ways truer, and it is the part I most wanted to reach with you. Not what a Blitzar is, but what it might mean for you, lying here in the dark, small and warm and briefly awake, beneath a sky that flashes with the deaths and cries of stars. I want to linger a little on the people and the patience behind everything we have described, because it is easy to speak of what we have learned as if the knowledge simply appeared, and it did not. Every fact we have touched tonight was won by someone sitting up late with data, checking and rechecking, doubting themselves, arguing with colleagues, and mostly waiting. The story of the fast radio burst is not only a story about dying stars. It is a story about human patience, about the long, unglamorous, deeply hopeful work of building instruments and pointing them at the dark, and being willing to wait years for the sky to say something back. Remember how the very first of these flashes was found. Not in a dramatic night at the telescope with alarms ringing and scientists rushing to their screens. It was found by a researcher combing back through old recordings that were 6 years old, going through them patiently, one stretch at a time, looking for something, anything that had been missed. The Lorimer Burst had been sitting quietly in that archive for 6 years, a titanic flash from beyond the galaxy, recorded and then forgotten, waiting for someone with the patience to look again at data everyone else considered finished. That is how much of science actually happened. Not in the flash of discovery, but in the slow willingness to look once more at what has already been seen, in case there is something there that the first look missed. And then think of the years of doubt that followed. For a long time, many careful scientists did not believe the flashes were real, or did not believe they came from far away, and they had good reasons for their doubt. The sky is full of false signals, and a single unrepeatable flash is the easiest thing in the world to explain away. There was even the famous embarrassment of certain bursts that turned out to be nothing cosmic at all, but the signal of a microwave oven in the telescope's own building, opened impatiently before its timer finished, its brief spark of interference mistaken for a message from the depths of space. Imagine the humility in that discovery, and also the honesty. The scientists could have quietly buried their mistake. Instead, they tracked it down, named it, and published it, so that everyone would know to watch for that particular fool's gold in the future. That willingness to be wrong out loud, to chase down your own errors and hold them up to the light, is one of the quiet glories of the whole enterprise. It is how the knowledge stays trustworthy. Slowly, the doubt gave way, not because anyone insisted, but because the evidence piled up until it could no longer be denied. More flashes were found. Their dispersion fingerprints kept saying, over and over, that they came from far outside the galaxy. New instruments were built specifically to catch them, and they caught them by the hundreds and then the thousands, and the reality of the flashes became impossible to argue with. This is how a doubted thing becomes a known thing. By force of argument, but by the steady, patient accumulation of evidence, one careful observation at a time, until the weight of it settles the matter on its own. It can take years. It can take decades. But it is the surest path to truth we have ever found. And picture, for a moment, what it must be like to catch one of these flashes today. Somewhere in a quiet control room, banks of computers are sifting through a torrent of radio noise from the sky, an overwhelming flood of static and interference and ordinary cosmic hiss, searching every second for the particular downward sweep that marks a burst, the high notes arriving first and the low notes trailing behind. Most of what the computers flag turns out to be nothing. A bit of local interference, a passing satellite, a glitch in the electronics. The scientists have learned to be skeptical of every candidate. But every so often the shape is unmistakable. Clean, bright sweep, dispersed by an amount that could only mean it crossed a vast gulf of intergalactic fog. A real one. A flash that left its source before the Earth was born, ending its billions of years of travel in a single thousandth of a second on the instruments of a species that has only just learned to listen. I imagine there is a particular quiet thrill in that moment, the recognition that you are among the first beings ever to know that this particular ancient flash arrived at all. There is a lesson in all this patience that reaches beyond astronomy, and it is a restful one to hold. The universe does not reward impatience, does not hand over its secrets to whoever demands them most loudly, yields them slowly to whoever is willing to keep looking, keep listening, keep building better instruments, and pointing them at the dark and waiting. The scientists who study these flashes have made peace with a pace of discovery measured in years and decades. They plant instruments the way a person plants a slow-growing tree, knowing the fullest harvest may come only to those who follow them. And they find, I think, a deep contentment in that long relationship with the sky, a contentment that has nothing to do with hurry. There is something in it worth carrying into your own life and into your sleep tonight. The good things ripen slowly. The deep answers arrive in their own time. And there is peace, real peace, in learning to wait for them without anxiety, trusting that what is coming will come. The instruments themselves are worth a moment of quiet wonder too, because they are among the most patient objects ever made. Consider the great sky-watching array that catches so many of these flashes, lying open to the heavens in its quiet valley, never moving, never aiming, simply drinking in whatever passes overhead as the earth turns. Does not chase the flashes. It cannot. It has no way to point at them. It simply waits, staring at a broad band of sky, letting the turning of the world carry new stars through its patient view, hour after hour, night after night, year after year, catching whatever happens to flash while it is watching. There is a kind of wisdom built into that design. It does not try to guess where the next flash will come from, because the flashes are unpredictable, and guessing would be foolish. It simply opens itself to as much of the sky as it can, and waits, and trusts that if it watches widely enough and patiently enough, the universe will eventually flash within its view. And it does. Hundreds of times a year it does. Perhaps there is a way of moving through the world in that as well. Not always chasing, not always straining to aim ourselves at the one thing we think we want, but sometimes simply opening ourselves wide to whatever comes and waiting, and trusting that if we stay open and patient enough, the world will flash something wonderful within our view. The great array does not worry about the flashes it misses. It cannot catch everything, and it does not try to. It catches what crosses its patient gaze, and that is enough, and it is a great deal. You might let yourself rest in that same posture tonight. Not straining, not chasing, just open and quiet and patient, letting the night carry over you whatever it will, trusting that you do not have to catch everything, that what is meant to reach you will reach you in its time, the way an ancient flash reaches a waiting dish faithfully at last after all its long travel through the dark. It is worth pausing, too, on just how crowded the field of explanations has become, because it tells you something about how young and how alive this mystery still is. When a question in science is truly open, when nobody yet knows the answer, the ideas tend to bloom in great profusion, one after another, each scientist offering a different possible maker, and the fast radio burst has drawn more of these guesses than almost any puzzle of our time. At one point, astronomers joked, only half joking, that there were more proposed explanations for fast radio bursts than there were fast radio bursts actually known. More than 100 different models have been put forward over the years, each a careful attempt to answer the same simple question. What could pour out days or decades of a star's whole light in a single thousandth of a second, again and again all across the sky? The Blitzar was one of the earliest and most elegant of these, and we have spent our night with it. The magnetar, the star with the impossible magnetic field, has since moved to the front because we caught one in the act. But between and around those two sit a whole quiet crowd of other ideas, and I would like to name a few of them for you, gently, not so that you can keep them all straight, but so that you can feel the richness of a mystery still being worked out in real time by living people right now in our own age. Some scientists have proposed that certain flashes come from the violent collisions of neutron stars, the very mergers we spoke of earlier, the moment two dense corpses of stars finally meet after millions of years of spiraling together. In the chaos of that collision, or in its immediate aftermath, a flash of radio light might be flung out, and then, if the merged object collapses into a black hole, silence forever after, which would make it, like the Blitzar, a one-time event. Others have suggested that some flashes might come from neutron stars colliding not with each other, but with other kinds of dense object, or from the sudden starquakes that crack a neutron star's rigid crust, or from a young neutron star still wrapped in the glowing debris of the supernova that made it, sending its flashes out through that hot expanding shell. And a few of the ideas reach toward the truly exotic, the frontier where physics grows strange, and here we must be especially careful to name a hypothesis clearly as a hypothesis, a guess and not a finding. Some have wondered whether certain flashes might involve theoretical objects that have never been confirmed to exist at all, hypothetical relics from the early universe, or exotic knots in the fabric of space predicted by some theories and never observed. These ideas sit at the very edge of respectability, offered tentatively, held loosely, tested against the evidence as it comes. Most of them will almost certainly turn out to be wrong. That is not a failure. That is exactly how the field is supposed to work. You offer every reasonable possibility, and then you let the sky, patiently, over years, rule them out one by one, until only the survivors remain. There is a great honesty in a science with 100 ideas and no final answer, and I find it deeply reassuring rather than troubling. It means the people who study these flashes are not pretending to a certainty they do not have. It means they are keeping every door open until the evidence closes it. It means the question is genuinely alive, genuinely unfinished, genuinely being argued over in papers and conferences and late-night conversations, right now, tonight, by people who care enough to keep guessing and keep testing and keep waiting for the sky to speak. A field with 100 ideas is not a confused field. It is a fertile one. It is a field where discovery is still possible, where the big answer has not yet been found, and where someone alive today, perhaps someone young, perhaps someone not yet born, will one day be the one to find it. And slowly, even in that crowd of 100 ideas, an order is emerging. This is the beautiful part. It is not chaos forever. As the catalogue of flashes grows from hundreds into thousands, and as we learn to localize more and more of them to their home galaxies, and as we catch more nearby events like the flare from our own galaxy's magnetar, the crowd of explanations thins. The evidence rules some out. The magnetar idea grows stronger with each new clue. The Blitzar holds its narrow ground among the one-time flashes. Many of the more exotic guesses quietly fade for lack of support. The field is doing exactly what a healthy science does, moving slowly, patiently, from 100 possibilities toward a handful of strong ones, and someday, perhaps, toward one. We are watching a mystery being solved, not all at once, but gradually, in real time, across a single human generation. That is a rare thing to be alive for. Think of what that means about the moment you happen to occupy. 1,000 years ago, no one could have wondered about a fast radio burst because no one knew light came in colors the eye cannot see. 100 years ago, the first of these flashes had not yet been recorded, and the very idea of a neutron star was brand new and barely believed. 50 years ago, we had never seen one of these bursts at all. And now, in your lifetime, in this narrow, bright window of history, we have found thousands of them, weighed the invisible matter of the universe with them, caught a magnetar, making one in our own galaxy, and narrowed 100 wild guesses down toward a few strong contenders. You are alive during the discovery. You are here for the part of the story where the mystery is being cracked open. Your grandchildren may grow up knowing the answer as a settled fact in a textbook, a simple line they never think to question. But you get to be here now, while it is still a wonder, still an open question, still a thing that living people argue about beneath the same flashing sky you are resting under tonight. There is a particular sweetness in being alive for the wondering before the answer arrives, and I would not trade it. A settled fact is a fine thing, but it is a closed thing. It sits in a book, finished, and asks nothing of you. An open mystery is different. It is alive. It invites you in. It lets you feel for a moment the same, not knowing that the scientists feel, the same pull of curiosity, the same quiet thrill of a question still hanging in the dark, unanswered, waiting. Tonight, you got to feel that. You got to hold a real, live, unfinished mystery in your mind, one of the genuine, open questions of our age, and to wonder about it honestly, without anyone handing you a tidy ending. That wondering is a gift the future will not have in quite the same way. So let it settle over you now, not as a frustration, but as a kind of privilege, the privilege of being here, awake, curious, alive, in the very age when the flashes were first being understood. And then, having felt it, you can set it down, the way you set down everything else tonight. The mystery does not need you to solve it before you sleep. It has waited patiently for years, and it will wait patiently a while longer, held in the careful hands of people who will keep looking long after you have closed your eyes. You have done your part simply by wondering. Now the wondering itself can soften and slow and fade like a flash receding into the deep, and you can let the great open question drift off into the dark where it belongs, and turn, at last, all the way toward rest. Before we turn fully toward rest, let us do one last thing together with the science, the gentlest and most vivid thing of all. Let us imagine, just for a while, that we could go and see it. Measure it from afar with dishes and clever mathematics, but truly witness it, safely, impossibly, the way you can only witness things in the soft theatre of the mind as you drift toward sleep. Let us go and watch a Blitzar happen. Take a slow breath and let the room around you fade, and come with me out into the dark. Imagine we're drifting, weightless and untouchable, somewhere far out in space beyond the edge of any galaxy, in a quiet stretch of the great dark. There is no up and no down here, no ground beneath you, only the slow, soft turning of distant stars in every direction, tiny and cold and patient. It is utterly silent, the way space always is, a silence deeper than any you have known, and it is not a frightening silence but a restful one, the silence of a vast room in which nothing needs anything of you. You are simply here, floating, watching, safe in a way that no real body could ever be. And ahead of us, growing slowly nearer, is the star. Not a bright, cheerful star like the sun, but a small, fierce, dense thing, no wider than a city, glowing with a strange, fevered heat, spinning so fast that if you could somehow see its surface, you would see it blur. This is the supramassive neutron star, the too heavy star, the one held open only by its own dizzying spin. It has been spinning like this for a very long time, thousands of years perhaps, turning and turning, bleeding its spin slowly away into the dark. And it does not know, if a star can be said to know anything, that its long holding on is almost over. It simply spins as it has always spun, at the very edge of what is possible. Come closer, gently. See how it is wrapped in something you can almost sense, a vast invisible structure of magnetic force, great arcing lines of it reaching far out into the space around the star and rooted deep in its spinning surface. For the star's whole long life, those lines have had their home there, anchored, faithful, sweeping around and around as the star turns, stirring the thin haze of charged particles that drifts around it. It is a machine of unimaginable power, this spinning magnetized star, and it has been running smoothly for ages. But it is running down. Each turn is a hair slower than the last. The great balance that has held for so long is drifting quietly toward its end. And now, as we watch, the moment comes. There is no warning, no gathering, no swelling of light to announce it. One instant the star is spinning at the very edge of what can hold it up, and the next instant it has slipped just past that edge, and there is no longer enough spin to fight the crushing pull of its own weight. And in that instant, the star begins to fall. Watch closely, because it happens faster than anything you have ever seen. The star does not crumble slowly. The whole city-sized ball, heavier than a sun, drops inward toward its own center all at once, at nearly the speed of light. In less time than it takes a single thought to form, it shrinks, past the size of a town, past the size of a single building, racing down toward a point. And around it, in the empty space where nothing should be, a boundary forms, a perfect dark sphere, a threshold beyond which not even light can climb back out. The star crosses inside that boundary, and it is gone. Where a fierce, bright spinning star hung a heartbeat ago, there is now a sphere of pure blackness, perfectly round, perfectly silent, giving nothing back. A black hole has been born before your eyes. But watch the space just outside that black sphere, because this is the moment we came all this way to see. In the instant the star vanished, its great magnetic field lines lost their anchor. The surface they were rooted in fell out of the universe, behind the horizon, and the black hole cannot keep them, cannot wear that tangled magnetic hair. And so the field lines, released all at once, whip outward into the space around the new black hole, snapping free like a vast bundle of cables cut at the base, recoiling, lashing the thin haze of particles around them. And as they lash, they drive those particles outward in one tight coordinated pulse, and the particles, shaken together, all in step, all at once, sing out a single clean note of radio light. Here, that is the flash. That is the Blitzar. If you could see radio light with your eyes, you would see the space around the black hole erupt for 1,000th of a second into a brilliance that briefly outshines everything, a single blinding pulse blooming outward in a perfect expanding shell, racing away in all directions at the speed of light. One flash, one clean bright note, struck from a bell in the very instant the bell is swallowed. And then it is over. Pulse races outward into the dark and is gone from where we float, and behind it there is only the black sphere, silent and still, and the cold, distant stars turning slowly beyond it, exactly as they turned before, as if nothing at all had happened. But something did happen. A star that had held itself open for thousands of years has finally let go, and in letting go it filled a corner of the universe with the brightest light it would ever make, and then fell silent forever. And that flash, that single pulse we just watched bloom outward, is now on its way. Will cross the empty space beyond the galaxy, and then the vast gulfs between the galaxies, thinning and fading as it goes, brushing through the invisible fog of the cosmic web, gathering its faint record of everything it passes. Will cross for 100 million years, and then 1 billion, and then billions more. Stars will be born and die while it travels. Whole galaxies will drift and turn. And all the while, the flash will race on, faithful to its speed, carrying the last word of a star long since gone. And then, one ordinary night, on a small blue world circling an ordinary star, the flash will arrive. Will wash over a dish of metal that beings on that world have built, for reasons the dying star could never have imagined, and a machine will notice, and a scientist somewhere will see a clean, bright sweep appear on a screen, and will know that an ancient flash has completed its journey at last. The star that made it will have been gone for longer than that blue world has existed. But its last word will have arrived, and been heard, and been wondered at, across an ocean of time and space so vast that the very fact of the meeting is a kind of miracle. That blue world is ours. That dish is one we built. And that wondering tonight is yours. Now let the scene fade gently, the way the flash faded into the dark. Let the star and the black hole and the cold turning stars all soften and grow dim, and let yourself drift back from that far quiet place, back through the space between the galaxies, toward your own small warm world, back to the room where your body rests, breathing slowly, safe beneath the blankets. We went out to witness a star let go, and we saw it, and it was beautiful, and now we can let even that image go and turn at last toward our own gentle rest. Let us begin with the smallness, because that is usually where the mind goes first, and because it is not the frightening thing people sometimes take it for. When you truly take in the scale of what we have been discussing, a certain vertigo can rise up. A flash from billions of light years away. A star heavier than the sun crushed into the size of a city. Energies that make our whole civilization's output look like a single spark. Distances so vast that light itself, the fastest thing there is, takes longer than the age of the earth to cross them. And here you are, one small warm body on the surface of one small world, one of 8 billion on a planet that is itself a speck circling an ordinary star in the outskirts of one galaxy among hundreds of billions. Against all that, it is easy to feel like nothing at all. But I would like to offer you a gentler way to hold your own smallness, one that I think is closer to the truth. Yes, you are small. Almost unimaginably small, set against the scale of the flashes and the gulfs they cross. But smallness is not the same as insignificance, and the two get confused far too easily. A thing can be small and still be precious. A thing can be brief and still be real. The flash itself, remember, lasts only 1,000th of a second, briefer by far than a single one of your heartbeats, and yet it is one of the most powerful events in all of creation. Brevity did not make it nothing. Size is not the measure of worth. If it were, then a mountain would matter more than a child, and we all know, in the deepest part of us, that this is not so. And consider what you are, exactly, in a way the sheer scale can make us forget. You are made of the same stuff as the stars. This is not a poem. It is a plain physical fact, one of the truest things science has ever found. The atoms in your body, the calcium in your bones, the iron in your blood, the oxygen you are breathing slowly in and out as you lie here, none of it could have existed at the beginning of the universe. In the beginning there was only the lightest and simplest matter, hydrogen and a little helium, and nothing else. Every heavier atom, everything that makes up a rock or a tree or a hand, was forged inside stars, cooked in their hot cores over billions of years, and then scattered out into space when those stars died. The iron in your blood was made in the heart of a dying giant, in exactly the kind of star whose death we traced at the very beginning of tonight. Calcium in your teeth was forged in a supernova. You are, quite literally, the ash of dead stars, gathered up and warmed into something that can wonder about the stars it came from. So when you look out at that flashing sky, or think about it as you drift towards sleep, you are not truly an outsider gazing at something foreign. You are a piece of the universe that has become able to look back at itself. The same processes that make a neutron star made the atoms that make you. The same gravity that crushes a supramassive star into a black hole holds you gently to the surface of your world and keeps you from drifting off into the dark. You are not separate from all that vastness. You are part of it, a small, aware, temporary part, the part that has learned to notice the rest. And that is not nothing. That may, in fact, be one of the rarest and strangest things the universe has managed to do. As far as we know, Awareness like yours is far rarer in the cosmos than dying stars. Neutron stars are common. A mind that can imagine a neutron star is, so far as we can tell, exceedingly rare. You are the uncommon thing. There is a particular tenderness I keep returning to, and I want to give it to you fully now, because it is the heart of what these flashes mean to me. Think again of a flash that set out on its journey billions of years ago, before the earth had formed, before there was a sun to warm it, before there was anything here at all. That flash crossed the widening dark for an almost inconceivable span of time. And out of all the moments it could have arrived, out of the billions of years before you and the billions of years that will come after, it happened to complete its journey now, in the brief flicker of history, when there are beings here who can catch it and care about it. Its whole enormous journey and your whole brief life overlapped in a single instant of arrival. That is a kind of meeting. A meeting across an ocean of time so wide it beggars the imagination, between a dying star and a waking mind, arranged by nothing but the patient speed of light and the accident of your being alive to receive it. You were alive for it. That is the gift, and it is easy to overlook because it costs nothing and asks nothing. Out of all the eras of the universe, you happened to open your eyes during the one narrow window when beings on this world had built the dishes to hear the flashes and the science to understand them. 100 years ago, no one on Earth knew these flashes existed. 1,000 years ago, the very idea of a neutron star, let alone a star ringing out as it fell into a black hole, would have been unthinkable. And 1 billion years from now, when the sun has swelled and changed and this particular chapter of life on Earth is long over, there may be no one here to listen at all. But right now, in this brief bright window, there is you. Yeah, awake. Curious. Able to hold the whole staggering picture in your mind for a moment before you sleep. That window will not stay open forever. It is open now. I do not say any of this to make the smallness heavier. I say it to turn the smallness into something you can rest inside, the way a small creature rests inside a vast and quiet night without fear. The bigness of the universe is not a threat to you. It has been here all along, holding you, whether you thought about it or not. The same flashes were firing across the sky on the day you were born, and on every ordinary day of your life since, hundreds of them a day, silent and unseen, while you went about your small, warm business of living. They did not disturb your life. They did not need your attention. They simply were part of the great calm machinery of a universe that has been running for nearly 14 billion years and will run for far longer still, a machinery you are a small living part of, carried along by it, made of it, at home in it whether you feel at home or not. That is the first thing the Blitzar means to me, and the first thing I wanted to give you. That you are nothing against the vastness, but that you are a small, aware, star-made, briefly living piece of the vastness itself, awake at exactly the right moment to catch a flash that has been travelling since before your world began. Hold that lightly as your thoughts begin to slow. You are small, yes. And you are also, in your own way, one of the most remarkable things in the whole flashing sky, because you are the part that noticed. Now let us take that thought and let it soften further still, and drift with it toward the deeper quiet where sleep is waiting. Let us stay a while longer with the deep time of it all, because time, even more than distance, is the thing these flashes stretch beyond all ordinary reckoning, and there is a strange comfort waiting inside that stretch. When you catch a flash that left its source 8 billion years ago, you are not really looking out into space at all. You are looking back into time. You are seeing an event that finished long before your world existed, an event that has, in a sense, been over for 8 billion years, and yet is only now arriving in your instruments as fresh news. The star that made it, if it was a star, has been gone for longer than the Earth has existed. What reaches you is its light, its last word, still travelling, still faithful, still carrying the message of a thing long since ended. Every time you look up at the night sky, you are doing a gentler version of this. The light of the stars you can see with your own eyes left them years, or centuries, or thousands of years ago. Some of the faint stars you might glimpse on a truly dark night poured out the light now entering your eye before the pyramids were built. You never see the sky as it is. You cannot. You only ever see the sky as it was, each point of light showing you a different moment in the past, all of them arriving together in your single present glance. The night sky is not a picture of the universe now. It is a vast collage of many different pasts, layered one over another, the near stars showing you recent history, and the far galaxies showing you the deep antiquity of the cosmos, all mingled into one quiet scene above your roof. There is something in that which loosens the tight grip we keep on the present moment, and loosening that grip is a fine way to drift towards sleep. We spend our days convinced that only the present is real, that the past is gone and the future not yet come, and that we must attend always to the sharp, bright edge of now. The sky tells a softer story. In the sky, the past is still arriving. The past is still real, still travelling, still carrying its light to whoever will receive it. An event that happened 8 billion years ago is not gone. It is still crossing the dark, still on its way to some distant dish that has not yet been built, on some distant world that has not yet formed. Nothing that has ever shone is entirely lost. Its light goes on, outward forever, carrying the memory of it across the widening universe, long after the thing itself has ended. I find that a tender thought to hold about our own small lives as well. We tend to think that a moment, once past, is simply gone, erased, as if it had never been. The universe does not seem to work that way with light, and perhaps it does not work that way with anything. The warmth of an ordinary day, a kind word, a quiet evening like this one, a moment of wonder before sleep, these things happen, and then they are woven into the fabric of what has been, and what has been does not unhappen. It recedes from us, yes, the way a flash recedes from its source. but it also travels outward, into the future, into the shape of everything that comes after it, carried forward the way light is carried forward, never quite lost. You are, right now, made of every moment that came before you, every choice of every ancestor, every scattering of stardust from every long-dead star. Nothing was wasted. It all arrived here, in you, tonight. Consider, too, the great invisible structure these flashes have helped us map, because it is one of the most beautiful pictures modern science has ever drawn, and it is a soothing thing to imagine as you settle. The galaxies of the universe are not scattered randomly through space, like sand thrown across a floor. They are strung together along vast invisible threads and sheets of matter into a structure astronomers call the cosmic web. Imagine a great three-dimensional net, or the delicate frame of a sponge, or the branching filaments of some enormous slow-grown thing, galaxies gathered thickly where the threads cross and thinning out to almost nothing in the great dark voids between. The whole universe, at the largest scale we can see, has this gentle, branching, web-like shape, matter drawn out along glowing strands with vast quiet emptiness in between. And the fast radio bursts crossing that web, feeling their way through its threads of thin gas, have helped us trace its shape, weighing the invisible filaments as they pass. The flashes are mapping the very skeleton of the cosmos for us, thread by patient thread. Picture it as your thoughts begin to soften. You are lying on a small, warm world, which circles an ordinary star, which sits on one of the fine, bright threads of that vast cosmic web, one glowing strand among countless others, stretching away in every direction across a darkness billions of light years deep. And along those threads, and through the great dark voids between them, the flashes are firing hundreds a day, silent and unseen, each one crossing the web and quietly taking its measure. You are a tiny living mote resting on one strand of the largest structure that exists, held in a web so vast and so gentle that its full shape took our cleverest instruments and our most patient minds a generation to begin to trace. And that web has held you, and your world, and your star, safely in its threads for the whole of your life, turning slowly, carrying you through the deep time of the cosmos, without ever once letting you fall. To know that you rest on such a thread, in such a web, held by such deep and patient structure, is not a fearful thing. It is, I think, one of the most reassuring facts there is. You are not adrift in a formless void. You are woven into a structure of almost unimaginable order and beauty, a structure that has been building itself since nearly the beginning of time, a structure that runs from the atoms in your blood all the way out to the largest threads of matter in the visible universe, all of it connected, all of it one continuous fabric, and you a living knot within it, briefly aware, resting now in the dark. The same web that the flashes are mapping is the web that holds you. You are not the observer of the cosmic structure. You are part of it. You always were. And tonight, on your small strand of the great web, you are safe, and you are held, and you are allowed to rest. So, let the deep time settle over you now like a soft and heavy blanket. The flashes have been firing for billions of years, long before you, and they will fire for billions of years after, long past you, and for this one brief warm night, you get to lie beneath, aware of them, at peace with them, a small living part of the very cosmos they cross. There is nowhere else you need to be. There is no other moment you need to reach. This one is enough. This one has always been enough. Past keep arriving in the light above you, and the flashes keep crossing the web around you, and yourself keep breathing slowly in the warm middle of it all, held by deep time, carried by the turning of everything, drifting now, gently towards sleep. There is a peace, I have come to believe, that lives on the far side of not knowing, and the Blitzar has been quietly teaching it to us all night. We came looking for an answer. What is a Blitzar really? And what we found, if we are honest, is that we do not fully know. We know what it would be. We know how it could happen. We know why someone imagined it, and we know that a rival idea now stands ahead of it, and we know that the sky is flashing hundreds of times a day with events whose makers we are still learning to tell apart. We did not get certainty. We got something better, I think, and gentler. We got a true picture with its edges left honestly unfinished. Most of the tension we carry through our days comes from wanting to close things that are not ready to be closed. We want the question answered, the matter settled, the story finished, so that we can finally rest. And the universe, patient and vast, keeps declining to hurry on our behalf. The Blitzar is not settled. The mystery of the flashes is not solved. And yet here we are, and the sky is beautiful, and the flashes are real, and the not knowing has not diminished any of it. If anything, the not knowing has made it richer. A solved mystery is a closed door. An open question is a doorway you can keep walking through, deeper and deeper, for as long as you live. So let the question stay open tonight and feel how little it costs you. You do not need to know what makes the flashes in order to fall asleep beneath them. You never did. All your life the sky has been flashing with these events, and all your life you have slept soundly beneath them without a single answer, and you were never in any danger, and you never will be. The great flashes fire billions of light years away in galaxies whose names we will never learn, and they touch you not at all except as the faintest whisper caught by a distant dish. They ask nothing of you. They do not need to be understood by you. They simply are part of the deep furniture of a universe that was arranging itself in grandeur long before you arrived, and will go on doing so long after. There is a great rest available in that, if you will take it. You are allowed to lie beneath an unsolved sky and simply be at peace. Think of how the star itself in the Blitzar picture finally lets go. For thousands of years it holds itself open by spinning, fighting, straining, cheating the limit, refusing to fall. And then, one day, the spin has bled away, and there is nothing left to hold with, and the star simply lets itself go. It falls. And the falling is not a failure. falling is the most luminous thing it will ever do. In the very act of letting go, of finally releasing the grip it had held for ages, it produces the brightest flash in all its long existence. A note so brilliant it may briefly outshine 100 billion suns. The letting go is the light. The surrender is the song. There is something in that I would like you to carry down into sleep with you, because sleep itself is a kind of letting go, a nightly surrender of the grip we hold all day. And it too is not a failure but a release, and out of it comes something quietly luminous, the rest that remakes us for the morning. You have been holding things all day. We all have. The small worries, the unfinished tasks, the words we wish we had said differently, the grip we keep on all the parts of our lives we are trying to keep from falling. And now, in the dark, you are allowed to loosen that grip, the way the star loosens its spin. You do not have to hold everything open tonight. You do not have to keep the whole careful balance from collapsing by force of will. You are allowed to let the spin slow and the grip ease, and yourself fall gently, not into a black hole but into sleep, which is the softest and safest collapse there is, and which returns you, unlike the star, to the light of morning every single time. Notice how quiet the universe actually is, underneath all its violence. We have spent the night on flashes and collapses and titanic releases of energy, and it can start to sound like the cosmos is a place of endless noise and catastrophe. But that is not how it is out there. Out there it is silent. Sound cannot travel through the emptiness between the stars, and so all these enormous events, the collapsing stars, the snapping magnetic fields, the mergers that shake the fabric of space, all of them happen in perfect silence. The most violent flash in creation makes no sound at all. Crosses billions of light years without a whisper, and arrives at our dishes as a change too faint to hear, and we only know it happened because we built machines to notice what our senses never could. The universe is not screaming. The universe is profoundly, almost unbearably quiet. A vast, dark stillness in which brief, silent flashes bloom and fade, unheard, across gulfs no sound could ever cross. There is a stillness like that available to you now, and it is the stillness sleep is made of. Let the room grow quiet around you. Let the small sounds of the day settle and fade the way the flashes fade, blooming once and then releasing. Let your breathing slow until it moves as gently as the turning of a distant star, in and out, unhurried, needing no effort from you at all. You do not have to do anything now. You do not have to solve anything, or hold anything, or reach for anything. The great slow universe is handling its own affairs, as it always has, weighing its own hidden matter, firing its own quiet flashes, keeping its own patient conversation going across the ages, and none of it requires your wakefulness tonight. You are permitted, at last, to rest. Picture yourself held, for a moment, in the true scale of things, not as a threat, but as a kind of enormous gentle hand. Beneath you, the earth, turning slowly, carrying you through the night, as it has carried every sleeper who ever lived. beyond the Earth, the Moon, and the Sun, waiting below the horizon to return in the morning. Beyond them, the other planets, drifting on their long, slow orbit. Beyond them, the nearest stars, and then the great wheel of our own galaxy, 100 billion suns turning together in a spiral so vast that light takes 100,000 years merely to cross it. And beyond even that, the other galaxies, hundreds of billions of them, scattered across a darkness so wide that the flashes take billions of years to cross it, all of it turning, drifting, flashing, resting, in a silence deeper than any silence you have ever known. And you held somewhere in the warm middle of all of it, small and safe and briefly here, breathing slowly, letting go. To rest beneath the infinite is to feel carried by it, if you let yourself feel it that way, and I would like to help you feel it that way now. So much of the time we stand apart from the universe in our minds, as if we were watchers pressed against a window, looking out at something vast and cold and separate from us. But that separation is a trick of thought, not a truth of things. There is no window. There is no glass between you and the stars. You are not looking out at the universe from somewhere outside it. You are inside it, made of it, floating in it, held by it on every side. The same gravity that shapes the flashing stars is what gives your body its weight against the bed right now. The same atoms that were forged in dying stars are what your slowing breath is moving in and out. You are not pressed against the window. You are part of the view. And the universe, for all its unimaginable scale, has been remarkably gentle with you. Think of everything that had to hold steady for you to be here, resting tonight. A star of just the right size, burning steadily for billions of years without flaring or dying, pouring out a warmth just constant enough for life to take hold. A world at just the right distance, neither scorched nor frozen, wrapped in air you can breathe and water you can drink. A long, unbroken chain of living things stretching back nearly 4 billion years, not one link of which was ever broken, every single one of your ancestors surviving long enough to pass life onward, across every ice age and catastrophe and dark night, all the way down to you. The universe that fires those violent flashes in the distance has, right here, in your small corner of it, held the conditions for your life steady and gentle for your entire existence. It flashes far away, cradles you close. There is a kind of belonging in that which asks nothing of you. You do not have to earn your place in the universe. You do not have to be worthy of it, or useful to it, or clever enough to understand it. You belong to it simply by being made of it, the way a wave belongs to the ocean, not as a possession, but as an expression, a temporary shape the whole briefly takes. The wave does not have to justify itself to the sea, does not have to hold itself up by effort or prove that it deserves to rise. It rises because the ocean is moving, and it falls back because the ocean is moving, and in both the rising and the falling, it was never anything other than the ocean itself. You are like a shape the universe is briefly making, here in the warm dark, breathing slowly. And when the shape softens, as all shapes do, nothing is lost. The atoms return to the great store from which all shapes are drawn. The wave settles back into the sea. It never truly left. I find, when I hold this, that the fear of smallness quietly dissolves and something warmer takes its place. Not the cold thought, I am nothing against all that. The warm thought, I am held by all that, made by all that, at home in all that. The vastness is not indifferent to you in any way that should frighten you. It is simply large, the way the ocean is large to the wave, and the wave is not harmed by the ocean's size. The wave is carried by it. You are carried too. Every night of your life you have been carried through the dark by a turning world, beneath a flashing sky, held by a gravity you never had to think about, breathing an air you never had to remember to want, and you woke each morning safe. You will be carried again tonight. You have only to let yourself be carried, to stop holding, to stop watching from the window, and to sink back into the sea that has always held you. Let the flashes, then, become something gentle in your mind, rather than something staggering. Somewhere out there right now, a star is letting go, and in letting go, it is filling a corner of the darkness with a brief and silent light. It is not a catastrophe. It is not a warning. It is just the universe doing what it has always done, transforming, releasing, moving on, turning old stars into new possibilities, scattering the stuff of one dead sun into the raw material of worlds and lives not yet begun. Iron that was flung out of a dying star billions of years ago became, in time, the iron in your blood. And the stars letting go tonight are scattering the makings of things that will exist billions of years from now, long after you and I and everyone we know have settled back into the sea. You are one link in that endless gentle passing along of stardust, one shape the flow briefly took, and when your turn comes to let go, the flow will carry on, and something of you will go with it, out into the making of whatever comes next. There is nothing to fear in that. There never was. The same softness that lets you fall asleep each night, trusting that the world will still be turning in the morning, is the softness that can let you rest inside the whole vast turning of things, trusting that the great flow will hold you as it has always held you, whether you are watching or not, whether you understand it or not, whether the Blitzar is real or not. You do not have to keep vigil over the universe. It itself for nearly 14 billion years before you arrived, and it will keep itself long after. Tonight it is keeping you. Let it. And so let your breathing slow a little more now. Let it move as quietly as light crossing the empty spaces between the stars, unhurried, needing nothing, going gently on. Feel the weight of your body against the bed, that small, steady pull of gravity, the same force that shapes the flashing stars, holding you tenderly to the world so that you cannot drift away. Feel how the room holds you, and the house, and the turning earth beneath it, and the wide night above, and the vast quiet cosmos beyond that, layer upon layer of holding, all the way out to the faint flashes at the edge of the seeable, and all of it, every layer, keeping you safe in the warm middle while you rest. You are small, and you are held. You are brief, and you are made of the oldest things there are. You are awake for one more quiet moment, and then you are allowed to let even that go. There is nothing left tonight that you need to carry. The star has taught us how to set a thing down. It held its spin for ages, and then it let go, and the letting go was the most beautiful thing it ever did. Now it is your turn to set down the day, gently, the way the star set down its spin, and to let the setting down be soft and luminous and complete. Whatever you were holding, you may loosen your grip on it now. It will keep until morning. It will all keep until morning. The universe is patient. It can wait for you. And you have earned this rest simply by being here, simply by being one small aware piece of a vast and flashing cosmos that has, against all the odds, learned for a little while to wonder at itself. So let the flashes become, in your mind, something almost like companions now, soft and far and kind. All your life they have been there, firing quietly across the sky while you slept, hundreds of them a night, unseen, asking nothing, disturbing nothing, simply blooming and fading in the deep dark, far beyond your window. They were there on the night you were born. They were there on every ordinary night since, while you dreamed, while you worried, while you rested and rose and lived your small warm days. And they are there tonight, still blooming, still fading, still crossing their unimaginable gulfs, a gentle constant flickering at the edge of everything, keeping their own quiet watch over a universe that has never once needed you to stay awake for it. There is a great permission in that if you will accept it. The universe does not need your vigilance. Never did. It ran its vast affairs for nearly 14 billion years before you opened your eyes, weighing its hidden matter, firing its silent flashes, drawing out its cosmic web, turning its 100 billion galaxies, all without a single moment of your attention. Will run them for billions of years after you have gone. And it runs them now, tonight, perfectly well, while you rest. You are not holding the sky up. You never were. You are allowed to close your eyes and let the great machinery turn without you, because it always has, and it always will, faithfully, gently, whether you watch or not. Feel, now, how many layers of holding surround you. There is the bed beneath you, and the warmth of the blankets, and the quiet of the room. There is the house around the room, and the ground beneath the house, and the great turning body of the earth beneath that, carrying you through the night at a speed you cannot feel, as smoothly as a child carried sleeping in a parent's arms. There is the thin, sweet air wrapped around the whole world, the air you are breathing slowly in and out, that has kept every sleeper safe through every night there has ever been. There is the moon, somewhere out there, catching the light of a sun that waits patiently below the horizon to return to you in the morning. And beyond all of it, the stars and the great wheel of the galaxy, and the web of galaxies and the far quiet flashes, layer upon layer of a universe that cradles you on every side. You are held and held and held again, all the way out to the edge of what can be seen. Your breathing slow a little more. Notice how it moves without any effort from you at all. The slow, soft rise, the gentle fall, as steady and unforced as the turning of a distant star. You do not have to make it happen. It happens on its own, the way the earth turns on its own, the way the flashes fire on their own, the way the whole vast cosmos keeps itself without needing to be told. Your body knows how to do this. It has always known. You can simply let it and rest inside it and be carried by it, breath after slow breath, deeper and deeper into the quiet. And if a thought from the day drifts up, some small worry, some unfinished thing, let it be like a flash in the far dark. Let it bloom for a moment, and then let it fade, and let it travel on outward, away from you, into the great patient distance, the way the flashes bloom and fade and travel on. You do not have to hold it. You do not have to follow it. You do not have to solve it tonight. Like the Blitzar's last note, it can simply ring once and release, and go on its way, growing fainter and fainter, until it is only the softest whisper at the very edge of your mind, and then not even that. Let each thought be a flash that fades. The space between them grow and fill with quiet. Remember the star and how it let go. For thousands of years it held on, spinning, straining, refusing to fall, and all that holding was not the beautiful part. The beautiful part came at the end, in the letting go, when it finally released the grip it had kept for ages and gave itself over to the fall, and in that surrender it made the brightest light of its whole long life. You have been holding on all day, as we all do, gripping the many parts of your life to keep them from slipping. And now, like the star, you are allowed to let go, to fall into any darkness, but to fall softly into sleep, which is the gentlest release there is, and which gives back to you every single morning the light the star could only give once. So set it down now, all of it, the way the star set down its spin. The day is over, and it was enough, and whatever is left undone will keep until the light returns. There is nothing more that needs doing tonight. There is nothing more that needs solving or holding or watching over. The flashes will keep firing without you. The earth will keep turning without you. The great slow conversation between what we imagine and what we observe will go on across the ages without you, patient and unhurried, and it will still be there in the morning, and so will you, rested, remade, ready to wander again. But not now. Now is for rest. Now is for the soft dark. Now is for letting the grip ease, and the breathing slow, and the whole warm weight of you sink down into the bed, held by a universe that has never once let you fall. Let the quiet come all the way in now. Let the room grow soft and dim and far away. The last images of the night, the small fierce star, the snapping field, the single blooming flash, the vast dark web strung with galaxies. All of them soften and fade like flashes receding into the deep, until there is only the slow rise and fall of your own breath, and the gentle weight of your own body, and the warm, safe dark all around you. You are small, and you are held. You are made of the oldest light there is, and you are exactly where you belong. And there is nothing left to do but rest. We began tonight beneath a clear and quiet sky, wondering about a single flash from the far edge of the universe, and now, having travelled all that way, past the galaxies and into the death of a star and back again, we find ourselves circling home, the way a long walk in the dark always circles at last back to the door. The journey that began beneath the stars comes back, gently, to where it started, to you, resting in the warm dark, breathing slowly, no longer wondering quite so hard. Simply at peace beneath a sky you understand a little better and fear a little less than you did when we began. Think back to the question we set out to hold. What is a blitzar really, and could a single flash from across the universe be a star dying into a black hole? We know now that we cannot answer it with certainty, and we know now that this is not a disappointment but a gift, the open doorway of a mystery still worth walking through. A blitzar would be a too heavy star, held open by its spin, slowly running down across the ages, and then, in 1,000th of a second, letting go, falling into darkness, and ringing out one last brilliant note of radio light as its magnetic field snaps free. Might be real. Might explain some of the flashes that come only once. Or the gentler, more common magnetars, caught flaring in our own galaxy, might account for nearly all of them, and the blitzar might be a rare and hidden thing we have yet to catch in the act. We do not know. And the flashes go on firing, hundreds a day, across the whole width of the sky, patient, silent, waiting to be understood. But you do not need the answer to rest. That is the quiet truth we found along the way. All your life the sky has flashed above you with events you could not name, and all your life you have slept soundly beneath them, safe and held, and you will sleep soundly beneath them again tonight. The not knowing was never a danger. It was only ever an invitation to keep looking, to keep wondering, to keep walking through the doorway a little further each time, across a lifetime, in no hurry at all, trusting that the answers are already in flight and will arrive when they arrive, faithful to their speed, indifferent to our impatience, carrying whatever truth they have carried all along. If you found some peace in this slow wandering tonight, you would be welcome to rest with us again another evening, whenever the dark feels wide and a quiet voice would help you soften into sleep. And if you know someone else who lies awake beneath the same vast flashing sky, someone who could use a gentle companion in the small hours, you might share this quiet moment with them too, so that they might find their way here, into the calm when they need it. But that is for another day. There is nothing to do now but stay and settle and let the night carry you. So let your breathing slow one last time into the softest rhythm it knows, the slow rise, the gentle fall, as unhurried as a distant star turning in the dark. Let your body grow heavy, sinking down into the warmth of the bed, held gently to the turning earth by the same quiet force that shapes the flashing stars. The room fade, and the last soft images drift away like flashes receding into the deep, and let the great patient universe keep its own watch over the night, as it always has, so that you do not have to. You are small, and you are made of ancient light, and you are exactly where you belong, resting on your small bright thread of the vast cosmic web, carried by everything, needing nothing, at peace. The stars will keep turning. The flashes will keep blooming and fading far away in the kind dark. And you can let go now, softly, completely, and drift down into the deep, still quiet of sleep. Rest well. Sleep gently. Good night.